works.
And I forgot to hook up my power supply, which I want to do because I don't want to have this thing go dead when I'm... Yeah.
Might give it a minute.
Give it a minute. Okay. All right, welcome everyone. This is a, all right, never mind. This is kind of a temporary fill-in talk because we had another speaker not make it. And so you're fortunately going to get me doing this talk without slides. This is pure feedback, pure live demo. So now, let's talk for a little bit about the problem of open source, and there's that real screechy sound. It's just coming, it's coming from like above. What's this? The other mic is off? Okay. Oh, well, thank you for having me, and I appreciate everyone's patience with the informal format. Okay, that really hurt.
Let's just see if it works without.
Yeah.
Because I think I even said try without the mic and let's see.
Yeah, well, we do have a recording going on, and I would really like to get people to have a chance to hear the recording if possible, or if somebody couldn't make it, be able to catch up. So, all right, so let's talk for a little bit about the problem of underproducing software quality. Now, we all know that users prefer to run software at a high quality level. And developers
prefer to maintain software at a higher quality level. Nobody wants to be working in an open source software project where you're kind of staying ahead of things and releasing software at a quality level that makes things hard to change, hard to manage, hard to make progress. The problem in software is that we persistently release code at a lower quality level than either developers or users would prefer. And kind of the other side of that problem is that software developers who produce a lot of value in the form of a public good tend to be undercompensated. Now, there's a huge set of literature on why do we value public goods but underproduce public goods. And there's a bunch of ways to try to deal with the problem of, well, here's a public thing that people like, and we need more of it. And of course, the biggest way to deal with that problem is to, well, let's create some kind of an artificial property right in a public good. Let's apply copyrights, patents, that kind of laws to encourage the production of some public resource like software. And of course, that type of problem, or that type of approach tends to feed into all kinds of extra transaction costs and problems with restrictions on speech, restrictions on business models, competitive concerns. That the proprietary approach will only get you so far. Other people say, oh, well, let's just use open source as a complementary good to something that somebody does make money on. So, hey, if you give away some kind of a network service, or if you sell some kind of a network service, then you give away the software that's a complementary good to that. So you've lowered the total cost of the combined good, which is the service plus the software. Another great example is network cards and network card drivers. They're logical complementary goods. If you produce a network card, charge money for the network card, you give away the driver because A, that means that the operating systems do all the maintenance programming for keeping your driver up to date on new versions of the OS. And B, the total cost of ownership of your network card is lower because people who are running the right OS already have the right drivers. So artificial property and complementary goods are kind of like how we've been band-aiding along of dealing with the problem of underproduction of a public resource like software. But it's clearly not working. We're clearly dealing with an ever-increasing, how many went to the keynote? Okay, we're clearly dealing with an ever-increasing problem of lower quality software, people under-incentivized to produce the software at the quality level that we need. Now, I'd like to propose a new way of dealing with this problem of under-incentivization. And that is, let's look at the problem from the point of view not just of, I'm an open source developer, I want to get paid more to make better software. Let's also look at the problem from the point of view of the downstream user of that software. Let's say an engineering program manager at a company that's incorporating that software into a larger project. Now, from the point of view of that downstream user, what looks like a sustainability risk and a compensation risk from the developer point of view, is an upstream dependency risk, and because of all the human factors and the complex dependency trees for modern software projects, it's extremely hard to quantify. You don't know, if you're building a substantial size software project that's pulling in open source from all over the internet, you don't know if you're going to have problems delivering on your project because the maintainer of your dependency's dependency is about to burn out or get a job working for a startup or something like that. As the program manager of a software project, you want to be able to quantify that risk and hedge that risk. Just like if you're General Mills shipping Cheerios, you can quantify and hedge your exposure to the oats futures market. If you're producing software, you should be able to quantify and hedge your risks of exposure to the software development process. So let's go over to the demo. All right, I am in the Pin Factory project, and what I'm going to do right now is I'm going to run a shell script that's going to launch the project. What this application is a very simple futures market that is directly tied to the status of a bug in a bug database. So if I'm developing software and I'm exposed to some kind of a risk because of a bug or an unaddressed issue in a software project that I depend on, then I want to be able to hedge that risk, and I want to be able to incentivize someone to fix what I need fixed. All right, let's see what my let's see if my demo holds together. Okay, so what I'm doing is I'm launching, in this case, a Docker container with the application running in it, and I'm launching 3 separate Firefox profiles for 3 separate local users. And hold on, do I have another copy running? Let me just kill something. All right, I'm starting up the Postgres database in the container. And we started up 3 users. Oh, yes. Yes, please.
Development time to to making sure that it will itself, enlist in fixing the bugs. So instead of buying the software, maybe necessarily, it will actually contribute to the upkeep of the software if it's using it. So if you get enough companies and you get with enough good developers, they'll all sort of like attack the bugs in the software. So they'll be paid by the company that's using the software and integrating it will be paying the cost of upkeep of the software. So it's like the more people you have using it, the more you will find that there are people who have ability to contribute to the source.
Yes, exactly. And so yes, repeat the question. Okay, I'm going to summarize the question briefly, and that is, if an open source software project is used by a company, and that company is the downstream user of that project, then won't that company either assign one of their employees to work on that software project, or won't that company hire someone who's into that project or allow them to spend some of their work time and computing resources on that project? And the short answer is yes, this is an incredibly successful model, and it has been incredibly successful for certain projects. We've seen really good examples of projects like, say, Apache Cassandra, where you've got a bunch of large-scale users of databases, of large-scale NoSQL databases that get together, and they all have developers who are wearing their Apache hat some of the time, and they're wearing their corporate hat as a downstream user of one of those many Apache projects some of the time. So this has been the idea of, well, let's have employees contribute to it some of the time, has been very successful, especially for big, recognizable brand name projects. Unfortunately, today you get into situations where even a simple website can have many layers of dependencies. So I might say, I might go to build my project, and I'm pulling in open source code from 60, 70, 80 different repositories. Now, of course, people like to joke about Node.js for doing this. You see this huge scrolling by list of Node packages anytime you build something with NPM. But it's really in a lot of ways, a positive trend. You've got not just Linux and Samba on my file server box, but now you've got software projects from many, many different sources all coming together to make your downstream project a success. And the answer to the question of, well, can't you manage your way around having your employees do it, is yes, you can do that for some projects. But realistically, you can't do that in today's environment where dependency trees are broad. You've got a lot of different projects that you're aware of. And dependency trees are deep. Each of the projects that you're depending on can also depend on others, going down many levels. So the transaction costs and the management burden for dealing with many different projects at once is something that means it's harder and harder to quantify your software risk. And thank you very much for asking a question. If anyone else has a question, please stick your hand up, and I'm happy to take questions in the middle of this. All right, great. So let's think about a real simple use case for futures markets in software bugs, and then I'll run through a demo on an actual bug that I pulled off of the live site. So, simplest possible use case is, let's say I have a blog, and all of a sudden I decide, well, I want emoji on my blog. So I check out the open source repository for the blog software package I use, and I see, hey, there's an issue on there for please support emoji. As a user, I buy a futures contract on that issue that will pay me in the event in the event that bug goes unfixed, and pay the other side of the contract in the event that it gets fixed by a certain date. Developer comes along and sees that offer out there in the market and says, hey, I know how to make this work. I'll add the emoji support. When that issue matures, the developer gets the money from the winning side of the futures contract, and I lose my money, but I get the feature, and I can have emoji on my blog now. Now, so far, this sounds a lot like an open source bounty model, right? Where you get onto one of these systems where you can put up money to get an open source person to do the feature that you want. The place where this is different from a bounty and has what we hope are some positive features over a straight bounty system is, in a bounty system, you've either got the extra transaction costs of figuring out which developer was responsible for fixing something, or you've got the friction of developers claiming issues in order to contend for a bounty. The place where this is really a problem is where you've got a bug that requires multiple skill sets to solve. So if I report a bug in a web application, and there's a problem in JavaScript and there's a problem in CSS, if it's on a conventional bounty system, somebody might figure out the JavaScript right away, but then they get stuck on the CSS. They don't want to disclose their JavaScript work because they're contending for a bounty on the whole thing. Meanwhile, someone else has figured out the CSS, they're stuck on the JavaScript, neither one of them ends up fixing the bug. So bounty systems tend to get stuck as people contend for being the one person to claim the bounty. Where futures are different is if that situation with the JavaScript and the CSS problem was in a futures market, as soon as you fix one side, you've got an incentive to disclose and share your partial work in order to increase the value of your position. So you can say, hey, I hold a futures contract in this, I did all this JavaScript work, it's totally nailed for the JavaScript, and if the CSS developer checks that out and it works except for their CSS, then they can buy out the JavaScript developer and share the reward. The end user and the project maintainer don't have to get involved. The overhead is a lot lower if you can trade the contracts freeform. So let's work through a simple example. Okay, in this example, I'm an end user of a project. I'm Adam. And Adam is going to look at the available issues in the market. And Adam has decided, let's see, which one of these issues does Adam really want to get fixed? Adam really wants toaster notifications. So there's a bug for adding a toaster notification when a new message becomes available. And by the way, this is a bug in Pin Factory itself. I want to add this feature for real. But in the demo, Adam says, hey, I want toaster notifications. So let's go through and look at the marketplace. Well, all right, there's no trading action on toaster notifications, but Adam wants this feature, so Adam will say, place an offer on this issue. Adam's going to put up 200 tokens. And in this case, Adam gets to decide how much the other side of the contract should put up. So Adam can say, well, I want to make whoever holds the other side of this contract put up 200 tokens of their own, so that we know somebody doesn't just come along and free ride for the rewards. So we know they have skin in the game. So Adam is going to say, I want the worker to put up 200. Adam is going to say fund, because they're funding a piece of work on the project. And Adam's going to say, let's have this mature on 21st March, earliest available maturity date. And now we can see the market fills in the details of the offer that Adam's making. The market says, if this issue is fixed on 21 March, you will lose your payment of 200 tokens. If this issue is unfixed, you will receive the contract payout, which reflects a transaction fee of 20 tokens. So there's a 10% fee in the market for resolving the contracts. We'll get back to the fees and how to avoid the fee in a little bit. So this is the offer that Adam wants to make. So Adam is going to say, place offer. And now we can see it shows up in Marketplace for this issue. And Adam has placed Adam has placed this one offer, and there are other offers available in the Marketplace. Okay, so this browser window is another session. I'm doing these with different Firefox profiles, by the way, so they're all Firefox browser, but they're completely separate sessions, which is really handy for multi-user demos. Here's Beth. And Beth is looking to write some software and make some money. So Beth is going to look at offers in the market. And here we go, add a toaster notification. Now, let's say Beth is really good at JavaScript and CSS and decides toaster notifications, I can make these work. So she's going to click accept offer. What accept offer does is it populates that same offer form that Adam filled out, but it's now populated with an offer that will take the other side of the futures contract. So in this case, if this issue is unfixed, you will lose your payment. So Beth's taking the other side of the deal. If this issue is fixed, you will receive the contract payout. Now, when Beth places her offer, there's a message at the top of the screen saying contract formed. So Beth now holds a contract on this issue. And when Beth goes to her contract page, there is a fixed contract of which Beth is the owner. Let's go back to Adam for just a second. Adam also holds a contract, but Adam holds the other side. So, any questions so far? Yes, in front.
Where is the worker supposed to get the initial tokens for in this example?
In every project that's onboarded, we populate the set of contributors with tokens that they're given as kind of their initial stake. So basically, the Pin Factory project is looking for open source projects to bring on, and these tokens are, for now, they're play money. And so what we do when we bring somebody on who wants to have their project hooked up to Pin Factory is we will hand out some tokens to people who show they have a record of committing to the project. And the project maintainer will also be able to hand out tokens to some of their key users. And for the stake problem, there are a lot of interesting ways for projects to make sure that every new developer comes in with a stake, but without just handing out tokens willy-nilly. We know how that goes. Okay, does that answer your question?
Somewhat.
Okay, thanks. All right, so 2 contracts are held, and it is now time to take a time jump. All right, we're going to time jump 15 days into the future. Now, what's happening inside the container here is that the database is being shut down, and it's being restarted as a child process of the fake time tool. So in our container test environment, we can jump time forward as much as we want. If we try to jump time backwards, then we might completely mess up our database integrity. So at the application level in the market, there's a functionality for jumping time into the future for doing demos, but you can't jump time backwards. All right, so our application is reconnected to our database, and here's our third user, Charles, and Charles is the project maintainer. Let's reload Charles here for a second, and you can see that from Charles's point of view, it's now the future, 22 March. And Charles has the ability to resolve contracts. All right, so what do you think? Did Beth write the toaster code? Come on, she nailed it. All right? Okay, Beth wrote the toaster code. And so Charles has already accepted Beth's pull request, and he's going to resolve the contract type as fixed. All right, so Charles gets his message that this contract has been resolved. So let's go back and see what things look like from Adam's point of view. Well, Adam doesn't hold any contracts anymore, but Adam has a message saying that his contract has been resolved, and Adam got 0 tokens from that. Here's Beth. Let's reload. Beth no longer has any contracts, but Beth has received a message saying that add a toaster notification was resolved, and Beth received 380 tokens. So let's summarize where those tokens came from. Adam put up 200. Beth put up 200. The profit for the winning developer was 200, and the fee that came back was 20. So 380 tokens is what Beth ended up receiving. All right, any questions so far? What happens if multiple people are bidding? What happens is that we can look at offers. Actually, there are no live offers on the market right now because they expired when we jumped time. Let's go look at the live site for just a second. All right, here's the live site where I'm logged in as myself. All right, so there are multiple offers in the marketplace, and offers can have different prices. So some user might say, I'm willing to put up 200 tokens to fix this issue if the developer also puts up 200 tokens. So in effect, they're offering to buy the unfixed side of that futures contract at a price of 0.5. Somebody else might make a better offer. So as the person who's clicking accept offer, you can choose offers to accept. So if someone else had gotten in before Beth and accepted that offer, then one person could end up holding the fixed side of Adam's original contract, but then another user might come along and make an offer on the same issue, and a different user takes the other side of that one. So there's no rule that says that only one developer can hold a contract on any one issue at a time. If people are collaborating, they might choose to split up the fixed side of that contract. Does that answer your question? Yeah, that's a big issue, and one of the most persistent problems for trying to manage open source is what they're calling open source metrics. And so Linux Foundation, among other places, are trying to figure out, well, given what we know about the activity on this project, how do we know, is it good now, and how well can this development team respond to issues that they run into in the future? And so today, it's extremely difficult to tell, well, is this project just done by people who are looking for something to do and would do it for free? Is this project done by people who have other demands on their time and are probably going to be leaving soon? We don't know that kind of information right now looking at open source projects. And so the price signal that's sent by where are contracts on this project's issues trading feeds some information out of that project into the group of downstream users who are considering or already running it. Yes?
Yeah, I was just going to sort of summarize that problem simply, and that is there either has to be very clear commoditization.
Hold on, let's get you on mic here.
Okay.
Yeah, I mean, the same sort of question arises. 30 years on Wall Street makes me think about this. Everything seems like a market, except, kind of to the other fellow's point, particularly a futures market, as they all evolved and to some extent became more sophisticated, but they all started from a point of what are they doing? They're commoditizing something. And so it makes it relatively simple to understand the value. And, you know, that's where it then starts to, you know, sort of back pressure into the question of the other question, and that is, you know, how do you just establish value? How does anyone assess the value? All these kinds of questions. I mean, it's otherwise, you know, a totally interesting idea, but, and, you know, markets are now fairly easy to create in almost anything, but the question is, how do you get a market in the terms of buyers and sellers? And the easiest way has always been to have a rather simple product.
You know, it's a question of knowledge too, because I know from Node that there's a guy, Syndosaurus or some guy who's like contributed hundreds of fixes to like Node modules, and he was one of the guys. He's one of the original Node programmers, and it's like he fixes things immediately. He's got so many, you know, pulls and fixes that it's. I'd pay. That's the first person I'd go to figure. You know, but I don't know anybody else. You know, like. But that's because I use Node and I'm a developer. So but how does somebody who has like less knowledge than me make a decision about the quality of the bids that they're getting? You know, so it's a question of knowledge. It's a really complicated issue. Really, you know. Yeah, that's why. Well, that's why you have to have it add sort of a system of like qualifications, like how many projects has somebody done, how have they done on it, what's the satisfaction level of, you know, eventually you have to build that into the system too. So.
Right. So we're looking at the problem from the maintainer's point of view, and the downstream user's point of view, and the point of view of the developer who needs to be incentivized. And so one big problem that people bring up with this is, well, how do you know that the maintainer is going to resolve these issues correctly, right? So would a maintainer be willing to close an issue, either say, no, this doesn't fix it, and result in a futures contract closing with the wrong status and the wrong person getting paid? Or might a maintainer not cooperate in the process at all? And the real answer has to include the maintainer's decision to evaluate the code as it comes in a fair and independent way. Because don't forget that the owner of the futures contract is completely decoupled from whoever might actually be doing the work. If you know that there's some extremely dedicated developer out there who's likely to fix something for their own reasons, then is it possible that the fixed side of that contract is taken by someone who's purely front-running? And so there's going to be a situation where the owner of the contract and the person who profits from the movement in the contract is different from the person who's done most of the work. So in that case, kind of the degenerate case of bug futures, it turns into a simple prediction market where people are just just trading on whether or not a certain thing will happen, and not so much an incentivization market. So prediction markets and incentivization markets are related. You can use a lot of the same code for both, but when you've got a true incentivization market, you've got more of the money feeding through to the people who do the work. And I agree that it's extremely difficult to tell, especially in a large developer population, who might be the appropriate person to do the work, which is why we take the almost radical step of decoupling and not having that assignment bit in the system. Yes. Hold on, one more up front.
What happens if a bug gets reopened by the maintainer?
What happens if a bug gets reopened by the maintainer? So the status that matters for resolving the contract is what is the status of this bug on the maturity date of this contract. So let's say we've got this toaster, the toaster bug with a maturity date of March 21st. And so somebody codes up an awesome implementation of toaster notifications, and it gets accepted, and then it turns out that the toaster notifications put way too much load on the back end, and every user who turns on toaster notifications has to turn them off because they're clobbering their server. And so the project maintainer decides to back out the toaster notifications. Well, if they do that, then that bug can be reopened, and the status is unfixed as of the closing date of the contract. One of the things that this system ends up requiring is good hygiene and updates in the bug tracker and helping it accurately reflect what's there in the code. Does that answer the question?
But could a malicious maintainer close something, then reopen it right after the close date?
Could a malicious maintainer can do anything, right? And so if a project has an untrustworthy maintainer, somebody who's not going to close their bugs either accurately or in a timely way, then a market can't emerge on that. So it's kind of like if you tried to do oil futures, but that one big valve in Cushing, Oklahoma was not metering correctly when the oil's actually delivered. The market can't happen without the accurate and up-to-date status in the bug tracker. All right, any more questions? Yes. Hold on a second.
So how would licensing work in this case? Can someone putting in for example, let's say there's a fix for a time-critical or operation-critical piece of software, but they want to own that fix. They don't want anyone else to have it. How would a maintainer of a project make sure that something like that doesn't happen in their project?
So that is a piece of project governance that the maintainer is going to check before putting that bug into the final closed state. And so if a project requires, say, a copyright assignment or a SCaLE or a contributor license agreement or anything like that in order to put a bug into a final closed state, then that's something that the maintainer would have to check before they before they mark it as fixed. And the reason why we've got fixed and unfixed here instead of some of the other statuses that people like to use in their bug tracking systems is for each project we hook up to this, we have to designate which states in the bug tracker are to be closed as fixed and which are to be closed as unfixed. There might be a project, for example, where they accept code and commit it to master, but they don't put the project into, or they don't put that bug into its last state until it's deployed or something. So in that case, for a project like that, we would say the fixed in the market equals deployed in the issue tracker. So project governance doesn't change, but there does have to be that mapping of this state in project workflow maps to the fixed state in the market. So back to the question of maintainers and putting work on the maintainer to resolve an issue. In a lot of cases, it's going to be very clear to both holders of both sides of the contract when an issue is either fixed or it's extremely likely to be signed off as fixed by the maturity date. So one of the things that a developer can do if the fix is up there, it's gotten positive reactions, it just hasn't been merged and closed yet. One of the things the developer can do is say, all right, I hold fixed on this. I'm willing to also buy unfixed at a very low price, of course. I'm willing to buy some shares of unfixed to offset my position. Now, the user is going to be looking at their view of the market and see, oh, this thing's fixed or as good as fixed, and I don't want to wait I don't want to wait for the future to get all the way to zero. So I'll take that offer. I'll get back maybe 5 tokens of the 100 that I put up. But that way, the developer gets paid right away. The user gets a little bit of their money back. And because those two futures contracts offset each other, there's nothing left for the project maintainer to be forced to resolve. So the project maintainer doesn't have to go in and pronounce judgment on something when the user and the developer agreed to resolve that futures contract by consensus. Another thing that can happen is if you're a maintainer or a sub-maintainer taking on some kind of a role within a project, you can buy out some of those developers so that they aren't stuck holding a position and waiting for their money. You can buy them out and hold them to maturity. All right. Any more questions? I think we're actually a couple minutes over time. Was this till 12:15? So, all right. And if you would like an account on the live system, or you'd like to hook up any of your open source projects to it to try it out in play money mode, please come see me.
Test, test, test. And this, does it have a, yeah, it does have a clip. Good show. I wore pants today specifically so I would have something to clip it to. I've worn a dress to a presentation before and gone, that doesn't work at all. Clip it back of your neck.
The fallback position is turn that off.
Yep.
Switch on top and turn this off.
Okay, and the switch for this is just on top here.
Yep.
So. I turned it on.
Ready? Get
Yep.
hyped. Ready for this?
Let's do it.
This sounds good.
Check, check.
Good. Okay, I guess we got enough in here. That's pretty loud. Okay, welcome to another great day at SCaLE. I hope you guys are having a fantastic time. We've hit the expo floor, caught a gang of great talks. We try to bring you something new and exciting every year. And right now, I got getting hyped up next to me on the stage. I got Heather Osborne. Give my lady a big hand. She's more than just great hair, she's great content. Let's give her a hand, and Heather, take it away.
Thank you. Welcome, everybody. My talk, Modernization as a Forcing Function. You might have attended my colleague's talk just before lunch. Mark Roden was speaking on preventing fraud at Ticketmaster. Mine is a little more laid back. It's a better post-lunch piece of information to follow along with. It's story time. Don't take a nap, but follow along with some story time. So a lot of what I'm going to be talking about is the tech debt that we've acquired over the years and how to get rid of it, whether it be through deprecation or whether it be through forcing it to a modern platform. Let's see if my clicker works. My clicker is going no. Technology issues. What do you know? Okay, so we can do this instead. So the retirement phase of the development life cycle is frequently neglected and significantly has greater costs than just leaving a couple extra systems online. I will share some of our experiences with technical debt in both hardware and software and the real costs around it. So how do you decide when it's time for something to go? Or what do you use the appeal of modernization to make it go? So why is this personal? You have right here a picture of my garbage disposal. I don't know how many of you do your own home improvement, but as I did this piece of work where I was replacing my garbage disposal, I went, this is the perfect analogy for what I deal with on a day-to-day basis in technology. This thing is sitting there for 20 years. It has calcified on so hard, reading the instructions on how to remove it, it says turn this thing. Well, this thing no longer turns. A can of WD-40 later, somebody stronger than me later, and we finally have it removed because the parts that it said should move didn't move. Sorry for the feedback. It took so long to get this thing off, and like I said, I felt like it was an analogy for how we treat our tech debt every day. 20 years of life as a garbage disposal, yeah, it's a very clear analogy right there. So why is this personal? So I'm going to tell you a little bit about who I am and why I care so much about it, who we are, who Ticketmaster is, and why Ticketmaster has so much of this to care about. Some of the challenges we're up against in trying to clear out our tech debt problems, and how do we start to fix it? And finally, a little bit of why. So let me introduce myself. I am Heather Osborne, Dark Queen of Ticketing. I picked up this name a really long time ago. A couple of my old colleagues are laughing because they remember when I got this name. I know where the bodies are buried. That's also why I'm the Dark Queen of Ticketing. So I've been at Ticketmaster for coming on 22 years. April 1st is my anniversary. April Fool's Day, my longest running April Fool's joke ever. I've ended up staying with Ticketmaster after years of doing the startup shuffle. After a year, I would get bored and move on. After another year, another company, I'd get bored and move on. The appeal of throwing plastic balls at each other didn't keep me interested. The appeal of coming to a very large-scale infrastructure with new challenges, interesting challenges, that kept me interested. I stuck around for a really long time. We joke that you're either at Ticketmaster for life. Why does it sound like there's a telex back there? Okay, I'm going to stand still now. You joke that at Ticketmaster you're either there for a year or you're there for life, and I'm working on the life side of it, and I am by no means the longest tenured person at the company. Myself personally, I came into technology sideways. I was a journalism major. I wanted to write about things. I found that I was good at fixing people's printers. I was good at fixing their computer. I was good at explaining why things were happening, getting things on the network. So it stuck. I sat in my car reading Unix books. I was going to say Linux, but back then it was Unix System 5 Release 4. I was reading the textbooks. I was reading the networking manuals and trying to figure out how to make things work together until I eventually got a tech job. And then the last thing here, I've been effectively on call for 25 years. When you've been on call for 25 years, admittedly I'm on call for management now, it's still you're on call. If somebody's calling you for something, it means that something big is happening. You're not just doing the, oops, that box fell over, let's fix that box. I want to make sure that everything is resilient. I want to make sure that everything has more automation. If there's a problem, you just click a button, you make it go better. And I want to make sure I get fewer calls. My social things that I do are not conducive to being on call. I'm a live music and nightclub aficionado. You're not going to want to answer a call when you're in a dark nightclub or a loud concert. You're not going to hear it, for one. And then also, I'm an avid long-distance runner. I have gotten calls when I've been 18 miles away from my car. I'm going to be a little while before I get back to my car, so can you deal with this? While running, talking on an on-call critical incident. It happens, and for reference, I'm also running the marathon tomorrow, so please don't call me for on-call. Tomorrow, I'll be running. I'm going to tell you a little bit about Ticketmaster, the same slide that Mark showed. So we are one of the largest e-commerce sites. We're the largest ticket marketplace. We're based out of Hollywood, California, though I have interesting endeavors walking to work in the morning. I have the characters like Spidey Whitey and Dirty SpongeBob, and it's always a challenge to get to work, and by the time I get there, I'm all hyped up for the day because I've had adventure already. So we sell 500 million tickets per year. We're out of 30 different countries, and we have 80 million unique monthly visitors. It's a ton of visitors. But I'm going to give you a little bit of the history of Ticketmaster. We were founded in 1976 by a couple of guys at Arizona State University. 1977, we sold our first concert ticket to Electric Light Orchestra. I think it was in New Mexico. 1996, we founded Ticketmaster.com. I started in 1998, so I was there from the very beginning. I was helping spin up the Mexico site was one of my first duties. 2010, we merged with Live Nation. And since then, we've been doing innovating, scaling, et cetera. We've got verified fan presence, ticket exchange, some of our newer technologies. Sorry, trying to find the least squealy space. So with the 1996, when we launched Ticketmaster.com, that was a Windows site. We were using a precursor to ASP, IDC HTX. It was basically the back end of ASP without all the fancy features. We used that for a really long time to the point where we'd go up to Microsoft and they go, you use what? Why are you using that? We had, I'm going to say, 2 front-end servers, 2 event database investigative servers, and then 2 transactional servers at the back end of it. And this was 1 data center, a single database, and so on. We expanded that drastically. We expanded to a second database, second cluster, second data center, you name it. And it just grew and grew and grew. We used to be running on a HP Vectra, which was a desktop gaming machine. And then we expanded from there and started buying real server hardware. So we've got the we've been around for over 40 years selling tickets, but we've also been on the internet for over 20 years. You're going to end up with a whole bunch of tech debt. So as I mentioned, we're one of the largest ticketing marketplaces, or we are the largest ticketing marketplace. We've got big scale and big challenges. So we have on sales. Basically, every Friday is a self-inflicted DDoS. You have traffic spikes that shoot through the roof. The older days of this, I would tell the vendors, we're going to fall over during the on sale. No, 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 that's impossible. CNN does 10x traffic that you do. No, we're going to fall over during the on sale. Can you come in and watch? And they'd come in and they'd go, oh. They would get the understanding that that same amount of traffic that you can attribute to CNN, we were doing it in a minute. And that was a lot of the problem. You figure there's 70,000 fans that want to buy tickets to our most recent big on sale was BTS, big K-pop band. You figure those 70,000 fans are trying to buy 30,000 tickets. You're going to end up with 40,000 unhappy people. Refresh, 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 refresh. And as Mark stated, he's got the queue now, so that takes a little bit of the load off the systems. But we didn't always have that. That's a more modern development. He mentioned the 4 million bots. Those 4 million bots are also hammering away at the systems. He's doing his best to keep them off of our systems, but we still are feeling a little bit of fallout from that for the on-prem infrastructure. So this is a little bit of the Ticketmaster tech scale. We've got more than 20 ticketing systems, and I'll get into what ticketing systems are in a little bit here. A couple of you already know this one. 250 unique products, 1,400 people in the product and tech organization, 15,000 network endpoints across the world. That's venues, that's kiosks, that's arenas. We've got a public cloud. We've got, this is our private cloud. I mentioned the 20,000 VMs on the on-prem private cloud. And then we've also started using Kubernetes. So this picture over here, I call this the Museum of Arcane and Archaic Technology. I realize not everybody here knows what this is. This is a VAX. And a VAX is our base for our ticketing systems. We took VMS and rewrote it to a custom Ticketmaster interface, TM VMS, VAX TMOS, and wrote it so that it could do what Ticketmaster does best, and that's turn out unique inventory as fast as possible. So VAX, stealing this from Wikipedia, is a discontinued instruction set architecture from DEC. It's from the 70s, assembly language. It's known for managing virtual memory. So like I said, we've got our custom-written OS for the sake of selling ticketing inventory. And because I'm on the infrastructure team, I did not want to be the one hunting yard sales looking for leftover VAX parts to put everything back together. Back in the early 2000s, we virtualized the VAX onto Linux, and we've been keeping things steady there ever since. So on that note, one of my colleagues said, lately I've realized my job is part engineer, part docent. So he's officially a docent for the Museum of Archaic and Arcane Technology. What's a docent? The guy who takes you around the museum and tells you all about all the tour guide. Exactly, exactly. So setting the stage, I've already said we've got high profile activity out of scope of pretty much what everybody else does. People cry if they don't get their tickets. Sorry, you've ruined my daughter's life. She didn't get her BTS ticket. I hate you. You're horrible. Ticketmaster, you suck. All over Twitter, of course. Oh, wait, I'm moving around too much. So with that, we have to hurry to innovate. We have to hurry to keep up with the scale. We have to always be on, always be paying attention. So we've got 40 years of building and innovating. We've got 20 years of being on the internet. you grow to support these self-inflicted DDoSes. You scale horizontally. You've got 2 clusters that serve the traffic fine while the traffic's gone up, so what do? You build 2 more clusters. Well, those 4 clusters serve it fine. What do? You build another 2 clusters in another data center to geographically load balance. You bolt things onto the side of other things. Well, you want this brand new feature. It doesn't fit in any of the existing code base. Well, what do? You tack it on the side, add another service to a box that does something completely different. You engineer a new thing to replace the old thing. So you build this great new thing. It's more efficient. It's more logically designed. It's architected instead of just organically grown over time. And then nobody likes it. So what you end up is 2 different systems running in parallel. Scoot over again. 2 different systems running in parallel, and then the teams restructure. And the people who were running the old thing are no longer running the old thing. The people want to run the shiny new thing. And you end up with a whole bunch of orphans with no support. What happens with orphans? This is some of the tragedy of our tech debt is we've restructured, we've built a new thing, people don't necessarily move to it, and you still need to keep this thing up and going at a production grade level of support. With production level usage, high traffic usage. So I have to, of course, include a Archer slide. I didn't include the phrasing one. I could have also come up with something that you would call out phrasing on, but I think we can do this is how you get tech debt. What I'm going to do here is call out the art of deprecation, and some of the pitfalls that we've been fighting with in trying to get rid of some of these orphans and some of the older things that we run. So how do you determine ownership? Well, once upon a time, we didn't have a service catalog. I was the service catalog. And the only reason I was the service catalog is because I had been around since the dawn of time. Ticketmaster ate my youth. I might as well get something out of the mix. Reading down a list of 200 servers, going, I know what that is, I know what that is, I know what that is. Hey, that belongs to that person, I know what that is. I'm ashamed to admit that I was doing that as recently as 2 weeks ago. We do have a service catalog. We've gotten everything logged into our service catalog, but one of the things is that it's not necessarily static. And right now it is kind of static. If people restructure, people reorganize, people don't claim the ownership of the new product, get rid of the ownership of the old product, you end up with stale data. So how do you find the owner of something that's been orphaned? You have the right answer. So yeah, you research, you look at a Confluence page, you pull up the old archived wiki, and you see if maybe somebody had talked about it in the past. You look at Jira tickets. Who built this years ago? You look up old emails. You ask the old timer. You look at the code comments. You run a netstat. What's connecting to this thing? Maybe the person who's connecting to this thing knows what it is. You look at the system logs. You look at the web logs. You look at everything. You finally get sign off that, yeah, that looks like it's an orphan. So what do? And as you said, you turn it off. This is a snippet of a real email. A couple of you actually saw this email, so they can attest to it. There are 70 remaining hosts that don't have an owner, or they're halted. They are taking up space on our hypervisors. What are they? We're going to get rid of them. We're going to halt them. We're going to destroy them. I'm giving you a couple weeks. Speak now or forever hold your peace. Well, so sometimes we break things. We shut down these boxes of unknown ownership. 3 days later, there's a critical incident. People are going, we didn't change anything. Our system's fine. We haven't even done a release in months. Why did we break? Well, we look over, and there's, in a health check, a mention of a service that's a dependency, and it says it's degraded. Well, that degraded service degraded the whole service above it. And once upon a time, when we were doing our more Java service-oriented architecture, we built into our health checks a dependency chain that said if this service is degraded, the whole service is degraded, and if it degrades too much, it's going to drop it out of rotation. It's great in concept, but unless you keep things up to date, it's going to eventually break things. the health check was looking to make sure it still lived there. So as I said here, we did the research, we did everything we could to try to find it, but there was no accounting for this legacy knowledge, this tribal knowledge that wasn't necessarily shared across the people who still existed at the company, aside from some random confusing thing in the back of my head. So what do you do when a one-off hack becomes a product dependency? We've had many applications over the years, as I mentioned. Things fall out of favor, and we start working to deprecate it. We build a new one. So we had this client portal. It was the front end for our old reporting tool. It was okay. It was on older technology. We were trying to get rid of it. It did its job decent. It had unique logins. It had password expiration. It had the ability to segment the data by clients, so you could only see that specific client's information. And it could be managed hierarchically by the support team. So, okay, it was fine, but it needed to go. It had already been determined that it was going to be end of life. So what do? Well, we need an identity solution ASAP. We need this yesterday. We don't have time to build one. Let's tack this thing on the side of it. Let's force this Lego into a mega block and get out the hammer, pound it, make it fit. And then what do you have? You have an end-of-life system that now has this new modern system bolted onto the side of it. What you do is you end up wrecking their roadmap because you need to get rid of this old system. This old system is going to be out of security compliance very soon unless you get rid of it. There was already a deprecation plan, but you just ruined that for everybody. So just because you can bolt something onto the side of something, you need to think about the repercussions of what it is that you're trying to do at that time. So this is a quote I stole off of Twitter. 3 stages of memory loss for a system. When can we remove this hack? Does anybody know why we do this? Nobody knows why we do this, so I'm afraid to touch it. That's the story of my life. Story of my life. I thought it was very appropriate. So dependency mapping failures. You want to implement shared services because you don't want to reinvent the wheel every time somebody is trying to solve a problem. You want to be able to use a shared API. You want to be able to use the same data. You want to be able to have access to the same customer information. But shared services are only as good as their subscriber lists. If you don't know who is using this shared service, which we do end up in that situation a lot of the time, if you don't know who's using it, you can't do maintenance. You can't plan for decommission it. You can't upgrade it without knowing what you're going to disrupt. We've used various shared services for our various sales channels, our mobile, our desktop, our IVR. And some of those things didn't necessarily tell us that they were using these services. So once we needed to upgrade them, we had to find all the customers that were using these things. And like I said, if there's not a registry of users that are using it, then you don't know who you're going to affect. How do you know when it's actually time to retire it? Do you know if all the users are off of it? You can ask, and you know you're not going to necessarily get a good answer. So retirement of this process gets delayed. Upgrades get delayed. Security updates get delayed because no one owns it. No one manages it. No one persists it in its modern state. And then here's the other one, ownership until death. I feel like I'm not the Dark Queen of ticketing anymore. I'm the Grim Reaper of ticketing. You need someone to actually own a system until death. Deprecation is part of the software lifecycle. Retirement is part of the software lifecycle. Everybody always ignores that because we made it pretty, it was great, it did its job, let's walk away. You can't walk away from things. So you establish an end of support date. That gets ignored, gets begged, people borrow time. People say, oh, well, we need just one more week, just one more week. Well, you got the end of support date, we're not supporting it anymore. So do what you will. Well, you also need to set a retirement date. The retirement date needs to be set so that this day we're turning things off. That date is also going to slip. We were just talking about this, a couple of my colleagues and I, that yes, we know it's going to slip, but it's still better that it's been communicated that this thing is actively going to be shut down at some point. If you have a product that you're moving to a different team, you need to have a team that's accountable for it. You can't tag it to just one guy, because that one guy is going to leave the company and not warn anybody. And you need to actually get a definition of when this thing has been successfully decommissioned. So next section, the high cost of end of life. It's more than just a couple of extra servers. So the long tail of retirement. There will always be somebody who's unhappy with the replacement. That last 10%. You set an end support date. You know that it's going to be shut down eventually, and you make it slightly more inhospitable. If we're not supporting it, it's not friendly, you're not going to get new features. If you want the new features, you need to move over to the new thing that we are very actively supported, and we have a full, thank you, Dave. We actually have a full team of people supporting and adding new features because this is the currently supported product. So it may slip and all, but you're still working on getting people to move to the new thing. The last 10%, at some point you need to rip off the Band-Aid, because this last 10%, you've got 10% of people using something that is a really poor showing for how great your company is and what good products they can give and what good support they can give. You have this janky thing that's run by 2 people and they're not getting quick action on it. Well, that's not our support level. That's not what we're trying to relay to the public. And then we have things that we'll say we keep old things because they're beloved and they're stable. That's not a permanent reason to keep things. So tribal knowledge and attrition. You didn't build this beloved, stable platform. Neither did your coworker. In fact, you look at the code comments and you don't recognize that guy from the gal. He's not in the gal. You don't recognize anybody who's ever commented on this thing. Oh, look, the documentation was last updated in 1996. Okay, that's going a little far, but there are things that I find documentation 2014. In internet time, that's a long time. What's GAL? Global address list. The Outlook mail address book. So find documentation that was last updated by Mark. So as I mentioned, the feature requests just kind of get bolted onto the side because you've got this beloved, stable platform. Nobody wants to touch it, but OK, we need this new feature, so we're just going to add another service running on the same box. Well, you've still got the developers on board. You can get a proper handoff. You can go chase down somebody and say, hey, Mark, how does this work? You can go ask a team before that team is disbanded, how does this work? You can get this information traded off to somebody. But if you have just full-on attrition, people leaving the company without actual warning, without actually handing off a product, you end up with a lot of unknowns. So there's other aspects, not just the software support, but the hardware support. Vendors are really good about telling us when their hardware's end of life, and unlike the software side, they don't have those fuzzy deadlines that we do. They say, we are no longer supporting this thing after January 2000. Well, people say, oh, we don't have time to move to that. It doesn't fit in our roadmap. OK, well, it works fine, maybe, for now. We don't have a support contract. It falls over. It's going to be catastrophic, and the vendor is going to go, ha ha. And you need to keep up with the rolling retirement of hardware behind you. So you spend time moving end-of-life hardware assets off because you don't want to end up in a situation where you have a catastrophic failure with no support contract. We've done one fairly recently. We had storage shelves that were going end of life in very short order. We had a segment of our root disks running on these storage shelves that were going end of life really quick. So what we had to do was, hey, these storage shelves are going end of life. You have 2 options. You can either migrate, reprovision these boxes yourself, which will put them on the new storage, or you can wait for us to do it for you, and that'll probably be at 2 o'clock in the morning when you really don't want to be involved in supporting it. So there's 2 ways to do that, and one of them is ask nicely and have them do it, or the second way of forcing them to do it, because at the end of the day, we need to get this old decrepit hardware out of there and move on. And then compliance. And I'm not going to go into too much detail here, much like Mark. Bad people also watch presentations, so I'm not going to give you the specific details of things. But one of the things you need to keep up with, particularly when you're processing credit cards and so on, is making sure you're on compliant systems. There's no glory in bug fixes. Nobody wants to spend the time in upgrading an OS or upgrading OpenSSL or anything else that might be required to keep their system modern and compliant. We have our yearly PCI audits, and it's a matter of chasing people until they get things done. And people put it very low on their roadmap. They need to actually schedule it into their planned roadmap so that you can get the proper attention onto it. Sometimes newer versions of components won't run on older versions of OSs. It's a forcing function there. You have to upgrade to be able to support this newer thing. We're not going to build you some really sketchy JDK that runs on your older OS, because that's not something that we want to support for the long term. We have things like that we support for the long term, and it's not a way to keep moving and modernizing in the future. The added issue with this is you have configuration management. You have to write in the exceptions. So on this version, you can't do this. On this version, you can't do this. You can't do this on here, and you can't do this on here. What you end up with is overly complicated configuration management, and complex systems are riskier systems because you can't just look at it and say, this is the expected result when you do X, Y, and Z. You need to extrapolate what's going to happen when you add A, B, and C, and G, F, and H on top of it. So modernization, how to get people to realize that it's important, and not just because we don't want to build their janky packages. So one of the things you need to do is classify your products. So we've recently started calling out things. The classification, you can put them in 3 different buckets. So we've got 3 here. And I talk ad nauseum about deprecate because, like I said, I'm the Grim Reaper of Ticketmaster. Encapsulate is more a modernizing those beloved legacy products in such a way that they're maintainable for an extended period of time. You still need to work on setting a retirement date for them, but we're not going to kill them off right away. And then we've got this last one, grow. I don't talk about that because everybody wants to grow everything. All the new information you got out here in the other talks, you're like, ooh, I'm going to run with that. I'm going to create this new shiny thing, and this is going to be great. And everybody wants to grow their new products and grow things from there. So tech maturity. We went from a legacy kind of siloed organization where we had systems engineers, we had operations, we had DBs, we had a dev team, we had a QA team. We had all of these things, and they're all separate, and they all did handoffs between tasks, between tasks, between tasks. So QA would hand off to the operations team to deploy, and so on. And you never really saw things end to end. The operations teams would watch the on-sales. They would sit there and observe the traffic, observe things spiking through the roof, observe things falling over when things spike through the roof. And then they'd go relay that back to the dev teams, and the dev teams would try to build something that they would think would fit with it, and that didn't work. When about 2015 or so, we switched over to the DevOps model. We gave the developers access to the systems. They started deploying their own code. They could monitor. They could watch what happened. They would get woken up in the middle of the night if they had a release that went poorly. They were the ones who got woken up instead of the operations team getting woken up, calling the dev team, and going from there. You had a lot of churn. You had a lot of time. Mean time to resolve was huge. So we created an environment where the product could watch, or where the product team could watch a product from end to end and see how things were going. So we got some good, some bad, and some growth out of this whole thing. You had now the ability to do fast releases, CI/CD. You could turn things around quickly, and you could do incremental releases instead of a 2-week development cycle where you had to wait and hope for the best when you did that release. So it greatly reduced our recovery time because the eyes that were on it were the eyes that wrote it. And it also gave better feedback up to the business because the person who wrote it and who knew what the problem was could tell the business exactly what happened instead of playing a game of telephone through an operations team, through a systems engineering team, and working their way up. Another notion of tech maturity here. Back in those days, we wrote a tech maturity model. It's basically the bare minimum that you need to move to the public cloud. And at that point, we were doing a really hard and fast drive to move everything to the public cloud. Hey, we're going to close our data centers one day, and it's all going to go to AWS. And like many companies have learned, that's not fiscally responsible. We wrote this tech maturity model so that we could look at how an application fit into the whole scheme of things. Is this thing resilient? Is this thing redundant? Does this thing react well to something falling over? Just a single node falling over? Do you have to go rebuild an entire cache because a single system fell over and needed to be restarted? Well, that sort of thing is not conducive to moving to public cloud. Public cloud instances are not nearly as stable as on-prem VM instances because there is no requirement that those things be 100% on. Exactly, exactly. So I call out no forklift. You need to have cloud readiness. You can't just take a legacy application that is sprawl everywhere. It was built for sprawl. It was built to tack on another cluster every time you needed to expand capacity. And those legacy applications, if they didn't think about how they were writing it and the fact that things wouldn't be always on, or that things needed to scale up and you needed some lead time to be able to scale them up, they're not necessarily suited for that environment. You also needed, because we no longer were allowing interactive login to EC2 instances, to Kubernetes, all of those things, you needed to build in the instrumentation to your code that allowed you the visibility to be able to assure that your system was operating properly. So you needed valid alerting, logging, and you needed debugging. You needed to be able to go, okay, well, let me deploy this little batch of code for debug, and let me get the feedback and see why it's not quite working right. You couldn't just SSH into a box and take a look at the logs and see what was going on. So this held very true for AWS and still holds true for Kubernetes. We have both, and both of these things, unless you have some aspect of maturity, you're not going to succeed there.
So you're managing your own Kubernetes clusters for your on-prem resources and you're using AWS for everything else?
No. We have Kubernetes on-prem. We have Kubernetes in AWS.
Your EKS, or you manage it there too?
We manage it there too. And AWS, we don't allow just bare EC2 instances anymore. It needs to be something that's able to be containerized and made more use of what resources that are there. So this is a little snippet of the tech maturity model. We open sourced this. If you saw on my slide, there was a link to our GitHub and so on. We're not as actively using this as we were originally when we first launched it, but it is still very useful information for the sake of, hey, is my application mature enough to be able to move into a public cloud or move into Kubernetes and move away from a VM to application kind of model. So another aspect of tech maturity, no hand-built boxes. You can't sit there and configure a specific node to do a specific thing manually. You need to use a reproducible deployment method. Ideally, you'd be able to codify the infrastructure as well. You need to be able to tear it down, run a script to rebuild it, some infrastructure as code, and be able to get that going. You need to be able to think about things in terms of Chaos Monkey. Like I mentioned, EC2, Kubernetes, those are made for flexibility and speed, not for permanent resiliency. If you do a regular rebuild of your non-prod environments using your codified deploy mechanisms and your infrastructure as a service, you can verify that even the most junior member on your team can rebuild the environment at the drop of a hat. You don't want to have to call that guy who's been with the company for 10 years to rebuild this special unicorn of a box, and when the systems team wants to do a maintenance on it, you don't want to have that guy show up because he's the only one who knows how that thing works. So as I mentioned, you need to establish a retirement date for your old products. So you stand up the new product, you need to have the retirement date already established for the old product. You need to figure out, if we're introducing this new thing and we've got it full featured at this point, you need to plan when that old product is going to go away. We don't just need a date. We need a plan. We need to know all of the consumers of your application. We need to know how they've been communicated to. We need to know the timeline of your plan. We need to know how you're going to clean up at the end of it all. Can you do a partial decom? So if you're collapsing your hypervisor footprint and you're making a change, can we collapse it down to 2 hypervisors from 50? Can we move everything over there? Is that enough resilience for keeping things going until you manage to get everything moved over so you can deprecate? So what needs to be cleaned up? As I mentioned, tons of orphans, the helper applications, things like this box that only exists for the sake of keeping this health check happy. You need to get rid of those. You need to get rid of monitoring. We use some third-party services for monitoring. You got Datadog, AppDynamics, Rigor, things like that. If you get rid of your product and don't clean that up, all you're doing is throwing money, throwing it. You need to clean up storage. We have so much storage in use because nobody bothered to clean up the queue trees after they decommissioned a VM. So you need to be able to call out that you've done that as well. And I see my coworker twitching over there. You need to clean up DNS. You end up with scads of DNS entries, and you go to look things up, and when you're trying to find the owner of an orphan, you go, oh, well, there's a DNS entry for it. Well, that just got left behind. CDN. We had Akamai and Fastly properties. If you don't clean up the old Akamai property that you used to use and you haven't touched in 10 years, you're just, like I said, throwing money. VMs. Yes, you might have idle VMs if you don't get rid of them. They're not using interesting resources, but they're still making it so you can't move things there. And this accounts for all environments, so pods, EC2 instances, et cetera, as well. You want to make sure that you get rid of those when it's time to get rid of those. That needs to be part of your cleanup plan. That needs to not be me asking, can I shut this down? Because nobody says they own it. And you need to clean up the service catalog. As I mentioned, we're defining all of these items in the service catalog, but the service catalog gets stale. So you need to make sure that you get rid of things that you are no longer actively running. At the very least, because people like to reuse names. And if you leave the old name and somebody builds a new one, we've had this happen a number of times. That's not that product from 1996, that's that product from 2002. No, not the product from 2008. So you need to make sure that you clean up after yourself, all across the board. And then you need a definition of done. Yes, we've successfully deprecated this product. So incentives for modernizing. As I mentioned, you want to drive people to modernize, not just clean up the cruft. End-of-life hardware is one area that gets hung up on the tech debt. What if I told you you could move your product to a brand new, highly performant flash array if you just made a couple of changes, cleaned up your software a little bit? That would be great. What if I told you you could move to a brand new, more robust network, new network gear, everything? What if I told you you could move to a less populated tenant because not everybody has cleaned up their stuff? That means you're going to murder this thing for a long time until everybody else starts moving in. Newer logging solution is available to you if you move over here. You could move to public cloud. As I mentioned, if you have your software maturity, you could move to public cloud. Or you could move to Kubernetes if you've matured in such a way that that is now an option for you. So we've also got non-modernization forcing. And that I should have realized was going to be a stumbling word. So sometimes you can't offer the new and shiny. Sometimes you need to put your foot down. And sometimes you need to do this to make a secure and stable infrastructure for your users. Sometimes you need to tell and not ask. Sometimes you need to ask for forgiveness and not permission. My example of the shutdown on this day, That's an example of telling and not asking. So we will be shutting down everything without a defined owner. That's one way of doing it. We will be changing access control so that any people attached to a product have access, but everybody else doesn't. So if you don't have your service catalog updated to identify that you own this product, you're no longer going to be able to access it. And any of these things that are end of life, we can say, well, you can't access it, so you needed to tell us. You needed to keep things modern. Another example, we will be turning off an insecure cipher on this date. You need to check your code. It is your responsibility. This is DevOps. You are responsible for making sure that everything we need to do to keep compliant is done. And we can't say, hey, you need to do this, because it just will never happen. And then we will be doing a DR of our critical systems on this date. Because we're DevOps, you own your product. You need to be the one responsible for making sure it comes up, making sure everything is functional after this DR. So we round you all up at 3 o'clock in the morning, and we have 40 teams sitting there. And this is for a DR for our filer in the first place. So we've got 40 teams sitting there. The 40 teams are going through and validating their code. And we said, you don't have to show up. If you have good enough instrumentation in your code and you get proper alerting to you so that you know that your product did not come back up correctly, you don't have to join us. You can wait until you get your on-call. I can say all except one team joined us. So that's one of those things like, okay, if you have instrumented your code properly, you're not going to get woken up unless something goes wrong. Otherwise, you're sitting with us and doing it with us. And then quantifying the cost of end of life. You look at how much time and energy you're spending on keeping things on life support. So everything can also suffer from culture debt and communication debt. You have the teams, all of this time, all of this churn, all of this back and forth to try to find out who owns this, who's responsible for it, who is going to deal with this thing. Too many teams do the out of sight, out of mind concept. And everybody plays a game of hot potato that causes a lot of strife, and a lot of inattention, because there is actually no answer. You waste time that you could be spending doing something useful. As I mentioned for the roadmaps, we put a bowling ball through your roadmap. You're going to do it at some point. So you end up wasting things. It's not just with the physical assets, the licensing, the public cloud. There's all of the wasted money on thinking that your capacity is a certain level, and it's not, because people haven't bothered to clean up. So another aspect of the cost of end of life, you have the culture and communication debt, as I mentioned, the blame game. Oh, no, they left it up. That's not ours. If it falls over, that's on them. Hot potato, passing it over, back and forth, back and forth. I think my job at this point is more talking to people and finding out what things are than it is actually doing something useful and modernizing. You end up with dissatisfaction. You end up with all these people that are stuck on managing these old products because they are the one guy that still knows how to do it, while the rest of their colleagues are working on the new, shiny, modern thing. So I've told you some horror stories, and I've told you some ways we've tried to work past them. I've told you some of the pitfalls on using some of these mechanisms to try to get things moved. And I've told you some ideas on how you can force a state of deprecation on your product stack, as well as ideas on how to motivate people to clean things up for this encapsulation phase, where you're going to keep something that's old and beloved and legacy until such time as a proper replacement and a proper item that can be grown to the future is established. So you can tell I feel pretty strongly about the retirement phase. Grim Reaper, my goal, though, is moving people towards modernization. I don't want to have teams stuck dragging the corpses of their old products behind them. I want them to be able to go work on the new thing. I don't want them to have to keep the old thing living indefinitely. Developers like to tinker. Systems people like to tinker. They don't like to just keep poking at the dead thing behind them. So we've got 40 years of tech debt dragging behind us. Let's release the old, shine up those new beloved items, and get people moving on to the new things. So I thought this was appropriate. We totally have professional grade numbers here. We don't have those rookie numbers. And this is my reason for Dark Queen of Ticketing have white cat fur on herself. But any questions? Yes? That's, so as I mentioned, we went from having the ops team and then having DevOps, and the ops team, once upon a time, knew the big picture, knew how everything interacted with each other, and knew that this thing did X, Y, and Z, and this thing did this, and if this wasn't working right, you went to this dev team. When you move to DevOps, you no longer have those guardrails that tell you how everything fits together, and I think that lends itself to creating a little more orphans. It's, I think, to some extent, it's a shortcoming of the DevOps model, because if you don't have the proper service catalog and the proper guardrails to prevent people from doing things like that, then you end up in that situation. Yes?
Are your slides going to be online?
Yes.
Okay.
I haven't yet. They asked us for our slides. I haven't provided them yet, but I will get them released.
Like just find them on the website after?
Yeah, I will get through the SCaLE site, wherever they say that we should put them. Mm-hmm. Any more questions? Any smart-ass remarks from my colleagues? How about a dumbass question from your colleague? Thanks, Mark. Yes? So Ticketmaster Vax, we do a global distribution, like for example, tickets in California are on a specific system and they're not necessarily shared across them. So it is very targeted per time zone, very targeted per market, because it's unique inventory. You can't spin up additional ones and you can't sell the same inventory twice. You need to have unique, which then makes it have to be regional. Otherwise, it's not going to work. Nobody else? Thank you.
1, 2, 3, 4, 5.
Well, hello there. Can I turn it off while I put it on so I don't kill anyone? Okay. Hello? Let me see. Hello? Hey. Whoa. Sorry, guys. that. All right, nope, I don't think I have it set up right. I might get the hand mic. I don't know. Okay, maybe if I don't move. My ear isn't shaped correctly. I think it's when I move my arm. Yeah, let's go that way. Are you an audio guy? I might need you to come up and help me out here. I'll go down here. Please assist.
I'm not an audio guy, but I'm an evangelist, so.
Thank you.
Turn you off for a moment.
I'm like, I am a new. Okay. Trying. Nope.
No.
Yeah, we're good? Yay. Now I just won't move. Okay. I mean, we're a minute away. I think we're good to start. All right, I'm going to start my timer here. Maybe, if I know how to click. Yay. All right, guys, thank you for coming to Confessions of a Sysadmin. Now, I promise that I will be completely honest and transparent through this entire talk, and that involves telling you guys that this is the hardest talk I've ever given, as I don't know how to use a mic. No, it is one of the hardest topics and talks that I've given because I don't want to say I've had a lot of enemies out of it, but I've definitely gotten a lot of judgment about it. And that's because this talk deals with the negative side of our community, especially when it comes to the Linux community and what I found when I joined. But I think all the concepts can be applied over open source as a whole. It's also a talk that I decided to write when I saw a lot of that negativity inside of me, and I saw me repeating the same patterns that I'd seen whenever I first started. So I thought, okay, you know what? I'm going to stand before my peers, I'm going to admit my sins in hopes that we can start having a conversation on how to fix these issues. Now, before I get started, I want to go ahead and introduce myself. My name is El Marquez, and I'm the community architect for a cloud guru, formerly a Linux. Sorry, guys, this thing is falling off my ear. Like that. Let's go to the hand mic. All right, yay. Okay, so I'm the community architect for a company called A Cloud Guru, and that involves doing so much. I am the co-host of Choose Linux. I'm a technology evangelist, so I come to conferences like this. I'm a training architect and did a lot of the Docker training in our environment. I used to be an OpenStack trainer, and I guess most importantly, before that, I was a Linux sysad. And I tell you guys not to say, hey, look how amazing I am. Look at all this stuff I do. I tell you this because what I am is a professional noob. And I swear I'm a podcaster, so I know how to use a mic. What entails being a professional noob is I don't take myself seriously. I dive into anything. I chase my curiosity. And so that's led to facing a lot of different communities with the acceptance of, I don't know. And last thing I want to cover is my slides are available at lopunk.com/confessions. The reason that I put this up here is I've done my best to put a ton of learning resources into my slides. So if you have any questions about the slides, click on the section that you have a question about, and it'll give you links on how to learn more. With that, let's get started with confession number 1. And that's when I joined the Linux community only 5 years ago, I wanted so desperately to be accepted by everyone. Like, I really thought that I would go to a conference like this and everybody would be like, "Oh, we're so glad you're here. You know, you want to learn something? Let's sit down and work together." And that's not what I found. What I found is oftentimes I couldn't get past the front gate. I couldn't get people to get over the being new. I couldn't get people to sit down and explain something to me without saying, "How do you not know this?" Without kind of judging me for being willing to answer and to ask questions. So my first confession to you all is that gatekeeping happens. I have seen a change in the community since I first started. In this last 5 years, to me, the community has really transformed. And I'd love to tell you that if you're new, that you're not going to face this issue. But the fact is that right now, we're in the middle of a war. And that's the old blood versus the new.
And I'd love to tell you that we're winning. So desperately would I love to come up here and tell you that we're winning. But the fact is that we're still in the middle of the war, and we're losing soldiers left and right. People are leaving the industry because of the negativity behind it. What I want you to learn out of this confession is that if you need help, if you face gatekeeping, reach out to your community. Because there are some of us, including myself, who are still facing this issue. Some of us that are putting our careers on the line by standing up. And that might seem a little extreme, but I can tell you, I've very much often feared being let go for my company by being one of the people that's the most vocal and standing up for other people. It's so ridiculous that even the question of what's Linux becomes a gatekeeping question. Because if I were to ask you, what's Linux? Well, if you were to ask me, I'd say, oh, it's an operating system and different distributions. And right when I got to that word, the trolls would begin to smile. And you'd see like the little hairs come up the way that you see on the Grinch, because they would tell me, oh, no, Elle, Linux is not a distribution. Linux is a kernel. And they would proceed to educate me with the history of Linux and how it started. And guys, we're past that point. Don't be ridiculous. At this point, when somebody talks about Linux, they're talking about the operating system, they're talking about the distribution, and you're not adding to the conversation. It got to the point where even our beloved dictator is being judged for this issue. You see, I got the opportunity to go to Open Source Summit, and this is huge for somebody at this point in my career. It's like going to a rock concert, because I walk into the keynote and the lights are dim, there's music going, there's a stage, and I'm that person who takes advantage of her friends, so even though I was late, I sneak into the second row and sit down. And I look up at the stage, and who's there other than Linus Torvalds himself? And I'm like, ooh, a little starstruck. I don't know that much about the man, but I'm excited. And the interviewer asks him, Linus, how do you know every line of code in the kernel? Like, how do you understand everything that's going on? And he says, I don't. And at that moment, all the laptop screens go up, the phones go out, there's light everywhere in this room. And everybody is tweeting and posting articles. Even Linus Torvalds doesn't completely understand the Linux kernel. Hoping some of you saw this. But they missed the point. They completely missed the point, because what he went on to say is he doesn't have to. He knows the end goal. He knows where the project is supposed to go. And knowing that end goal gives him a starting point. He can look at the lines before, he can look at the lines after to see if this commit is going to fit. And that to me was a little bit life-changing. It's a strange thing to say given who said it, but my lessons that I learned is what I need to do is I need to look at the big picture. I don't have to be obsessed with what the end goal is. This really is a marathon, not a sprint. And if I have a starting point, that gives me a point where I can dig in, I can learn something new, I can be excited about what we're doing again. And I also learned that gatekeeping happens. But what I learned out of that actually came from my friend Jason. Because I went to a conference and I did this talk, and he got inspired to speak right after me, went and talked to the organizers and snuck in even though he hadn't been accepted. In the middle of his talk, he stops and looks at me. He goes, Elle, do you know what a hacker is? I was, well, I mean, yes, it's somebody who gets behind the command line and breaks into systems. He goes, no, that's a thief. And he said, what a hacker is somebody who has a bit of curiosity, and they chase it, and they don't let anything stop them. They have to figure it out. And he said, Elle, you're a hacker, so why are you trying to go through the front gate? Jump over the fence and get on with what you're doing. Now, if some of you have a few questions about this, I've included Jason's website on the site that will give you more information about hacker meaning curiosity and a way that you can chase your dreams. I also included a webinar that I did that covers what the Linux issue, but you know what? You don't have to use Arch. What you need to do is pick the distribution that's best for you. Now that can carry a bunch of different aspects to it. For example, what's your workload? Are you looking to start a server? If you're brand new, I would strongly recommend that you start with either Red Hat, CentOS, Fedora, and Ubuntu. Why? Because that's where your best documentation is going to be if you're looking at running a web server, if you're looking at learning PHP to, MySQL, whatever it is that you're looking to do. So even if you're using it on your desktop, those skills are going to transcend to your job, and you can get better at it. Next is going to be, what features are you looking for? When I was looking for a distribution for my kids, I wasn't looking for package management and a beautiful GUI that I could change and command line interfaces that could use Flatpak. I was looking for something that they couldn't screw up and that didn't have easy root access, because I do have a teenager who will go for root access. So it all depends on the job that you're wanting to do. And though it may seem insulting to some people, really keep in mind your skill set. If you're brand new, you learned what Linux was at this conference, and somebody told you to go home and install Arch, ignore them. They're trying to gatekeep you. I'll call them out right now. Go and look at documentation. Just pick it, don't even install, go and look at their docs and see if they speak to you. I recently went and reviewed Solus. If you haven't listened to Choose Linux, this is new news, don't tell them that I told you all this. But I went and reviewed Solus, and I was going through their documentation, and they literally have step-by-step install pictures. Not words, pictures. Your screen should look like this. Click here. Meme of a funny cat telling you how you can screw it up. This is so user-friendly, and it spoke to me. Some people might look at that and go, oh my God, that's so annoying. Why don't they just give me the white pages? Guess what? Probably not for you. But with that said, the lessons that I learned here were, use the right distro for you. Don't let anyone else gatekeep you, because I promise you, whatever distro you pick, someone's going to tell you do it wrong. If you picked Arch, someone's going to tell you, well, why didn't you pick Gentoo? It's going to keep going. And work smarter, not harder. It's okay to have a second laptop where you're tackling Arch. It's okay for it to take you 6 months to do it or longer. It's okay to give up in the journey when you no longer have that curiosity. Don't lock yourself into a distro. I hate seeing people who treat distros like religions, and they become a religious warrior. Ubuntu is the only distro you're ever going to need to use. Learn, grow, and you know what? Go out and be a zealot for education, not for a single distribution. Overall, my message to you here is keep learning. Confession number 3. And that's when I started as a sysadmin, my team told me, use all the tools available to you. Learn how to use grep, learn how to use awk. And when I said, you know what, the easiest thing to do is to use the GUI, I was completely pushed aside. I was told that I would never be a good admin. I would never be a real admin if I continued to use the GUI. I think this is such a ridiculous statement. And like everything in life, there is an XKCD comic to explain this point. And I'm gonna get some water. All right. I know that we all would love to be in that moment, like, oh, I got this. And I love presenting this at conferences, especially when it's not a Linux conference, because I can see people doing this. Like they're trying to figure it out in your head. Guys, you're never going to be in this situation. And if you ever are, I mean, we're already done with to begin with, so this is never going to happen. And the reason I judge people is this becomes such a fighting issue of how do you not know this? Of course you know the flags. The flags are whatever. You know what I do? I go push the button. Simple as that. And I went to a conference where I presented this, and the guy's like, well, actually, L, unzipping and G-zipping, and I'm like, oh my God, no, I don't care about your tar file. My file opened, I got it to work, have fun. The most interesting part was when I went to go take a certification test. And now I'm going to tell you that I can't tell you what certification test that is because I'm under an NDA. But if you go to my LinkedIn, strangely enough, all my certifications are listed there, so I'll tell you this one. But I went in, and I'm in the room, and I'm taking it with several other people because it's proctored. And I go and I turn it on, and all I hear is tap, 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 like angry tap, tap. And I'm like, what is going on here? So I'm reading it, and we're having to set up networking. And what people are doing is an MCLI, tap, tap, board, tap, tap, what's the next thing? You know what, I went and clicked on the corner with the little icon about networking, and then I filled in the boxes, and I moved on. and that's my lesson to you, is learn to use all of your tools. Look, if I invited you over to my house because I'm decorating, and we need to hang some paintings, and you show up with a wrench, we can get the job done. Trust me, I've done it before. But if you showed up with a hammer, our job's gonna be a lot easier. It's like I told you guys before, work smarter, not harder. Learn to use the tools in the appropriate use case. I'm not telling you not to learn the command line. If you want to go work for a web hosting company, if you want to learn how to use Ansible, if you want to learn how to program, yes, you are going to need these tools. It doesn't mean that you have to use them in your day-to-day. If you reach that breaking point where you no longer like what you're doing, step away and just get the job done. Confession number 4. Anybody who went to my talk yesterday knows how much I agree with this one. Technology just sucks sometimes. Yesterday I gave my talk called Saving Lives, and it's a subject I'm very passionate about. I have cried putting that talk together. And it was something I really wanted to impart with people, except when I found out I was giving it, I was on the plane, and the talk was no more than an idea in my head. So I'm putting all the slides together, I get in the room, I'm nervous, and we can't get the slides up on the screen. And the way that I have my stuff set up, I either get my slides or my notes. So you know what, we went slide free, and it was terrifying, and I got off the stage, and I was just broken about it. But the fact is that I gotta get over it. That's not my fault. It is not my sin to bear. It's just technology sucks. Thank you. And this is one of my favorite tweets because I was so down on myself. Look, I was trying to start SCaLE in a VM. I've been using Linux for 5 frickin' years. How can I not get a VM up and running? So I posted this, and that kind of led me to remember that community really does matter. Because what somebody came back to say is, learning from a failed attempt is not failure. Sometimes software is just goofy, and it's not the operator. And I kind of discounted this message to begin with. I was like, yeah, whatever, hundreds of people can get SCaLE running, that's just me that can't. And then I had hundreds, and I'm not exaggerating, people telling me that they'd faced the exact same issue. Like, oh, use the OVA, that's obviously broken. Well, it wasn't obvious to me because I spent the entire day feeling like a failure. So how do you deal with this? Well, I'm gonna tell you that the community doesn't always do this. Because I've been distro hopping for a while for our podcast, which means that I change operating systems every 2 weeks. As you can imagine, not every one of them was a winner. And I would go on Twitter asking for help, being like, all right, community, I need you right now. And I'd get somebody going, well, what do you do? And I got tired of that, and so I decided to call them out on it. And I built a GitHub in which I put every single screenshot of what I did, I dumped my history file, and I put my error logs in. So when somebody came and said, well, Elle, what did you do? I'm like, oh, here's an example of exactly what I did. Here's the error logs. You're going to help me troubleshoot, right? Nothing. So call your community out. Don't be afraid. There are plenty of us, like I told you, who are out there fighting. We'll help you. And you know, honestly, I didn't have to confront the trolls because plenty of people came to my aid. Which leads me to confession 4B. And this one's hard to admit, but I've kind of admitted to it a bit throughout this talk, and that's when things don't go as planned, I blame myself. I come out here and talk to you guys, and I tell you not to do it, and I preach the word, and then I go home and I blame myself for all of my limitations, even though the limitations are often on the technology and not my ability. And I think that the perfect story for this is when I transcended from a Linux baby to a Linux toddler. And that is, okay, so I'd been on the floor as a Linux admin for 6 months. I finally understood what my job was, and they left me off the phones. I could actually work on customer service now. You have to remember, or I guess I have to tell you, that when I was a Linux admin, they didn't put me in the baby area. They threw me in multi-million-dollar accounts. I was working with banks and huge companies, which I'm not allowed to say, but you know, I really like cereal. And so I'd finally gotten there, and my team had decided was going to get my 3rd monitor. Now, if you've ever worked for a company that is a cheapskate, you know that your 3rd monitor is a big deal because the company doesn't give it to you. Your team goes out and they steal it from you for somebody that left. So I got my monitor, and I'm really excited, like my mentors believe in me. And I put it on my desk, and I plug it in, and nothing, black screen. Okay, display, nothing. Spent about 30 minutes working on it, and I'm like, oh, they're going to take it away. So I go around trying to talk to people about it, and my friend Allie, who helped me write this talk, was going through the same deal. And she tells me that she went to her mentor. Her mentor looked her right in the face and said, "How do you work here?" Followed up by, "Well, you know, if you're a real Linux admin, you'd use Arch." And she spent the rest of the day trying to figure out how to install Arch on her computer. I was really lucky that my mentor Corey and my mentor Kevin were a blessing. They never judged me for what I didn't know. They always put it on themselves. It wasn't, "How do you not know?" It was, "How have we not taught you yet?" So I went to them, and they sit down, and I mean, Corey to me is a Linux god. So he's sitting there on the command line, and he's like, I can't get it to work either. Mind blown on my behalf. So Kevin comes over, and he's like, "Oh, this is an interesting bug. Hey, Elle, you get to learn how to write a bug report." And we went all the way up to the top of our company, who then filed the bug report with Red Hat. Wasn't my bad, but plenty of people, including Allie, were made to believe that it was their lack of skill on why this didn't happen. And this led to my lessons. What I learned is it's okay to be new to things. Every day is going to be something new. You're not going to be perfect at everything you learn. And that means it's okay to fail sometimes. And honestly, I'd encourage you to push your skills to the point where you're failing, because that is when you're actually learning something new. But most importantly, enjoy the journey. Seriously, why are you doing this if you're not having fun? Does this mean that I love my job every single day? No, trust me, follow me on Twitter. You'll hear everything. I air all my dirty laundry. But at the end of the day, when I was at dinner last night, somebody asked me, if money wasn't an issue, what would you be doing? And I really thought about it. I'd still be doing this because I love what I do. Secondly, join the community. You don't have to do this alone. There are plenty of people out there who are willing to talk Linux with you. So join us on chooselinux.show, shameless promotion there. But really, we will tell you what distribution we're hopping to about a month before. Take the journey with us. Communicate with us. Tell us what issues you're having. You would be amazed at how much you can learn when we're working together. And be willing to share your journey. I'm lucky enough that my company was crazy enough to give me my own podcast with all of like 6 months worth of experience. And I started documenting my journey into InfoSec. And I would run into a problem where I didn't know what to do, and I'd throw it up on Twitter, and somebody, "Oh, it's really easy." And I said, if it's easy, come podcast with me and teach everybody else. I'm not looking to hoard knowledge for myself. Confession number 5. Despite all this, and despite telling you that I air all my dirty laundry, I'm still actually really scared to admit what I don't know. I feel that because of my job, everyone expects me to be a subject matter expert. I wrote training on Docker. Now this is Docker 101, and people still look at me like I'm a complete fraud when I don't know Docker networking. I was asked to help during a Kubernetes workshop today. Even here, you would be amazed at how many people discounted me when I didn't know how to fix their specific issue on Kubernetes, even though I haven't used it for over a year, and I admitted to that. I just wanted to help because the workshop wouldn't happen if they didn't get volunteers. But you know what? This is me most days. That's me on Twitter. It's okay not to know. It's perfectly fine. Like I said before, if you're not hitting a point where you don't know, you're not learning. In fact, often whenever we interview people, that interview doesn't start till you say your first "I don't know." Because then I learn how you troubleshoot. I learn how you think, and I learn whether you're going to be a fit for our team. Which kind of goes to this, which is one of my favorite comics. Which leads to the rest of confession number 5. Guys, if you're going to come ask me for help, and you know I want to teach, I am there. But if you ask me a question that I can tell that you haven't bothered trying to answer at all on yourself, you know what? I'm going to gatekeep you. I'll own it right here. And that's because you don't learn anything if I just tell you and you've done nothing. And as much as I hated it when my mentors told me this advice, I'm going to tell you guys. Go ahead and read that friendly manual. One of the things that I want you guys to know is what separates a baby sysadmin from a senior sysadmin is one thing. They're Google foo. Googling is a real skill. Don't go onto Google and say, what is the protocol that? You have to learn how to choose your words. Somebody just cringed over there. You have to learn how to choose your words, use the expressions, Specify what site that you're searching for, because that's really what's going to set you apart. And there's a few people who are like, I don't use Google. Do you know what they do to your privacy? Fine, use DuckDuckGo. Same concept. But don't limit yourself to that. There are plenty of people in this community that have dedicated to making their project better. So let's talk about Stack Overflow. This is a very important resource to me. And that's because Corey Quinn gave me one of the best lines. There are some of us that are front-end developers. There are some of us that are back-end developers. There are some of us that are Stack Overflow developers. And that just stuck with me. But if you go and use Stack Overflow and you put your question in, and then later you come back and say solved, I hate you. Tell me how you solved it. It happened once that I was looking for the answer for a question, and I found my question from like 2 years ago that was the exact same thing. And I'm scrolling up, and then I find my answer, and I documented it, and I was like, wow, past me is amazing. With that being said, also rely on the documentation for a project. Now, I'm the first person to call out that there's a lot of projects where their documentation sucks. Fair enough. As much as I rag on Arch, their documentation is amazing. I have used it so many times for other distributions that aren't Arch, but contribute to those projects that you use. If you go to the documentation for a product and you can't figure out the answer, and then you figure out the answer and you stick it on your own personal wiki, again, I hate you. Go contribute it to the rest of us so we don't have to keep reinventing the wheel. And that brings me to the lessons that I learned here. Google is your friend, documentation is your friend, and write the freaking docs. Confession number 6. I don't have a CS degree. I have absolutely no training when it comes to computers. In fact, I'm a theology major. My biggest dream in the world growing up was changing people's lives. I wanted to give away all the comforts that my parents had worked so hard to give me and go to a country where I could give back to someone else. I wanted to learn how to live off the grid. And in fact, when I graduated college with my amazing theology degree, I did go live off the grid for a while to learn what it would be like when I went there. And at some point, life went really, really bad. I have a whole talk about that. And I found myself in a situation where I was almost homeless. And I had a situation to go to some Linux training that they were going to give for free because I was a woman. And you know what? I took advantage of that diversity card. And I went and I learned how to use Linux. And my first day on the job was the first time I owned a computer. What set me apart, what made me good at what I did, was I was curious. I can't help it. I want to learn things. And that kind of puts me in my next confession. Part of this one is, yeah, I attended a boot camp. And you know what? It didn't make me a command line ninja. Too many boot camps are just obsessed with getting you to pass that test. They're a test dump, and that's not going to get you anywhere. Because I promise you, when you step in that room, we smell our own. And if all you know is the answers to those questions, but I start asking you about your home lab, and you're like, what's that? I don't have one of those. Okay, well, what do you do in the cloud to set it up? Oh, well, I read this book. Guys, nothing beats hands-on practice. And I'm not telling you that to be gatekeeping. That's seriously what you have to do. If you want to work with Linux, you're going to have to touch that keyboard. And that kind of leads to the next confession here. And that's, I chase certifications like they're wild geese. Seriously, it's one of my favorite pastimes. But I'm going to tell you that despite having spent thousands of dollars on certifications, it's never gotten me anywhere. I got my first job because of that boot camp, and every job that I've gotten since has been through community building. When I needed a job, somebody said, you know what, have you talked to Elle? She's really great, let me get her in. I've passed the front gate that way. The certifications that I get, I do for myself. I got my Red Hat certification when one of the admins on my floor did a ticket review for me. And he looked at me and he sent me an email attached with my boss that said, I could automate you. I felt like I didn't know anything. I wanted to leave my job. I was a poser. There was no way that I could be a Linux admin. I only had 6 weeks of that boot camp. So I studied for the cert, and I passed it for myself to prove to myself what I knew. And then I got my AWS certification. I actually got my OpenStack certification. I forgot to put it on here. And right now I'm working for my CompTIA certification. I'm striving to get my Security Plus. Not because it's going to really do anything for me, but because somebody said, Elle, if you want to know InfoSec, you have to learn the terms. You have to be able to speak logic problems and cross-site scripting. You have to condense your language because we have a short attention span and we'll forget what you asked. That was difficult for me, but you know what? I'm trying, and I'm going to go and I'm going to take the test, and if I do pass, that's awesome. That's for me. I got a little badge for myself, and if I don't pass, it's going to give me an idea of what things I need to focus on so I can better learn the lingo and people will accept me as part of their community. Because despite everything I've said, I still have that feeling inside of me where I just want to belong to a community. So the lessons that I learned here is nothing beats hands-on experience. I can proudly tell you here, even though I was embarrassed at the time, that I am the first and only person at that boot camp to reach kernel panic level. That also means I was the first person to learn what a thin client was, because luckily they didn't trust us on real machines. I'm the first person to learn what backups were and how important they were, and I was the first person to learn how to restore my environment from a backup. I worked with enterprise-grade accounts, and I can't tell you how many times those skills came in handy. The next thing is labs. Look, it's well and fun to go in and use Linux as your desktop environment. But if you want to do more, then you have to actually go in and play with things. Set up a virtual machine, download Ansible, get a cloud server, play with that. It's going to cost you pennies. Plenty of these organizations will give you small servers to play with. And another shameless plug, if you go to a Cloud Guru, we have a cloud playground for you to play with. All right, but seriously, it's not only your knowledge that's going to set you aside. Do you really want to set yourself aside in this community? Do you want people to know your name? Do you want people to put you up for that job when it comes up? Then give back. Teach others what you know, because I will challenge you right now. You can think you're the best at anything, but if you can't sit down and teach it to somebody, you're not as good as you think you are. Confession number 7. I've used a Mac OS box to do Linux syswork. And guess what? I didn't hate it. And that's because Mac protected me from myself. Do you know how many Linux admins that I saw spend more time trying to fix their own box because of an upgrade they tried to do? And I don't mean like apt-get update, I mean their upgrade that they tried to do. Mac has a certain amount of control where I couldn't screw myself up. I still had my environment, and I could still work on Linux work because I just SSH into a box, and guess what? I was on Linux. Which kind of leads to this next one, and I double said it there. All right, which leads to this one, and some of you already know this, and I'm hoping I don't have to run off the stage for this now, is I'm using Windows right now. I used to tell people with this badge of pride, you guys don't understand how prideful I used to see when I would say, I've never used another OS other than Linux. I was never a Windows user. What I was admitting to right there is that I went into this industry with one hand tied behind my back. I let pride get before knowledge, because I want to transition into InfoSec now as part of my job. Guess what? A majority of the boxes are running that I'm going to need to be able to pen test and protect. You know what's making a lot of money right now because it's the new buzzword beyond Kubernetes? WSL. Do you know who has a really easy time learning WSL? Linux admins who know how to use Windows. I've screwed myself over. So you know what? I'm standing at a Linux conference right now using Windows, and though I fear for my life a little bit, I'm not ashamed. The process of learning Windows, guys, was not easy. It's not as easy as we all make it out to be, like, oh, you really want to learn how to use a computer, use Linux. You know what, I can spin up a new computer every single day. It took me 4 days to try to figure out how to do a USB install of Windows. Like, I'm using a Linux box. You can't do that and put on a USB for Windows. It was horrible. But I got on, I got my computer on, I installed WSL, I used Visual Studio Code, once again, don't throw anything, and I was able to write my page, push it through WSL into GitHub, up to Netlify, and build my page. And let me tell you guys, I did a happy dance. And I got on Twitter and I celebrated my success. After everything that I've done on Linux and my career and everything, this was one of my most shining moments because I did it by myself. I read the docs, I set it up, I didn't break it, and I didn't have to ask anyone for help. It was awesome. On a side note though, I'm telling you guys a lot of things that require a lot of resources. I'm telling you to have a secondary box. I'm telling you to have, environments to play with. On a side note is, you don't have to have a lot of money to do this. You don't have to have an obstacle. Like I said before, I don't talk that much about it, but I was in a situation where my children and I were almost homeless. I didn't have the money to go buy a computer, and everybody says, oh, you should have just gone to Goodwill and bought a computer. No, we're at the situation, if I'd done that, my children wouldn't have eaten. It was bad. And let's be realistic, because after all the hops I've done, buying hardware at Goodwill is going to screw you over because it has the worst amount of resources. You're already trying to play with an unfair playing ground, and now you're setting yourself up for failure. Nothing against Goodwill. When there is a dedication, where there is a curiosity, there's a way. And this is a wonderful man who I forgot to put his name on my notes, but he's teaching in a small village in Ghana. And he's trying to set his students up for success. So he is drawing exactly what a word processor looks like and all of the icons that are going to be on top so that these kids can get a leg up on the market. And he did that with several different types of software. If you are in this room and you've had to borrow money to come here, perhaps your scholarship, and you need help, talk to someone in this room. My distro hopping machine right now is one that was donated to me by a wonderful listener of Choose Linux. And I couldn't accept it. I was like, no, I can't do this. This is too much. And he told me that it's one of the laptops in his pile of e-waste that he just can't get rid of because he collects all these old laptops. I promise you, a lot of people in this room have the same pile, and they're going to be willing to help you out. When I was trying to start learning and I didn't have a computer, somebody made a live USB for me. And I would go to the library and I talked to the librarian, told her my situation, and she would allow me to boot it on the computer at the library so that I can learn. Curiosity, guys, is what's going to set you apart. Reach out to your community. Somebody in here probably has a pocket full of live USBs. So if you've been listening to all this and you're like, all right, Elle, I get it. There's its downside and there's its good side. But you know what, Elle? I'm curious. I want this. I want to be set aside. Let me give you a little advice that I've learned on how to get started. First and foremost, choose Linux, or choose Mac, or choose Windows. Whatever it is, you can continue to learn. I know people hate on it a lot, but virtual machines can really set you aside. I'm learning Kali Linux at the same time that I'm learning Windows. I set it up in a VM and I can learn both at the same time. Your journey doesn't have to be limited, and if you become a zealot of one operating system, you really are limiting yourself. Learn automation. Now, this is one that I really struggled with because there's Chef and there's Ansible, and I don't know what to learn. Learn whatever works for you. You know how I started learning Ansible? It's because I distro hopped so much that I was trying to figure out how to make sure that my backup's always loaded up and then I had my environment figured out exactly the way that I wanted. Is that completely over-engineering something? Absolutely. But if I ever go apply for a job and they ask me if I know automation, boy, do I have a story to tell them. And this one I have fought tooth and nail, and I'm still fighting it, to be honest with you guys, and that's learn scripting. I'm not a developer. I can't think the way that these magicians do. They create something out of nothing, just a blank page. And my mentor, Corey, who I talked about, used to tell me, you have to learn scripting, Elle. It's just so essential to your career. And he would stay after work, and he would sit there, and he would try to teach me, and I would try to learn, but I was so stuck in my ways that I didn't need it, that I wasn't paying attention. 3 years after the fact, you don't know how badly I'm kicking myself. Because my chances of doing so many things would be so easier if I could just run a one-liner instead of a 15-line bash script. And that goes to have fun. You have to have fun if you're wanting to do this. I hit a part of my job where I didn't listen to my advice, and I wasn't having fun, but I just kept telling myself, just push through it. You'll get there, right? You'll enjoy the journey again. This is just part of the job. And the only thing that happened is I hit burnout, and it was ugly. Burnout and depression mirror their symptoms, and you will internalize everything that you never would have. If you catch yourself no longer enjoying the journey, pivot. Find something that you'll enjoy, even if it's just for a month. Give your brain and yourself a chance to breathe. Okay, so there's some of you who are standing out there going, okay, I don't know if I should have come to this talk. It's really just targeted to new people. So my advice for you, I usually say neckbeards, but I'm going to go with graybeards, is all of the advice that I've given today also applies to you. And this is the part where I make enemies, and I'm perfectly okay with it. If you are not learning and you are not growing, you've become stagnant. And if you've become stagnant, you've become the old blood, and I'm telling you, just get out of the way. You've become worthless in this industry. Kubernetes is changing every 6 months. OpenStack is changing every 6 months. Hell, sudo just got an upgrade to what, 1.9? You have to keep learning in this industry. So, you can use Arch, fine. Use whatever you want, but continue to learn and play with your tools. Have you ever thought about maybe building your own Linux? The mentor that I talked about earlier, Kevin, was getting bored with his job and he has a curious mind, so he built his own Linux distribution called Kubuntu. It worked great. I mean, he probably is still using it to this day. My favorite Linux distribution ever. Unfortunately, doesn't exist anymore, but it was Aurora. Look, I have broken every single operating system that I've used except Aurora. Developer did it for fun. He just came up with it, he was writing it, he was doing it for his own skills, and then he open sourced it. Nobody else took it, unfortunately, and he closed the project down when he wasn't having fun anymore. And I still write him mail asking him to continue. True story. Distro hop, have fun. There are new distros that are coming along every time, and some of them suck. Do you know how to develop? Contribute to the project. Write documentation back to the developer that is not your distribution sucks. Give him ideas. Look at the logs. Tell him what was going on. Many of these distributions are passion projects for people, and they love your constructive feedback. Give back to your community through knowledge, if I haven't made that clear enough. The new blood, we want your mentorship. We want your help. What we don't want is you to be condescending. Don't tell me, how do you not know that, and proceed to preach to me. Sit down. Teach me how to learn something. Yeah, I can read the docs, and I probably have, but what I can learn in 4 weeks of reading the docs, I can learn in maybe 40 minutes of you sitting me down and showing me what I'm supposed to do. And what about that hands-on experience that I told you about? I know that this isn't an InfoSec conference, but guys, these tools are going to be invaluable to your journey. Are you new to Linux? Go to Over the Wire. They have a Capture the Flag contest, and if you go to these slides off my website and just click on it, it will take you there. So I see all the cameras out. If you just go to the very first challenge, like you know nothing about Linux other than what you learned here. Click on the first one, and your first flag is going to be learning how to use the man pages. Your next one is going to be learning how to use grep, then cat. And it just builds up your skills to the point where I'm learning reverse engineering now. I don't know what the hell I'm doing, but I'm trying. Try Pico CTS. This is a great one because it's targeted towards high school students. And once a year, it goes live. You can form teams of 5 people. And the way that I form my teams, it's me, the newbie. I have somebody that does web app penetration, and I kind of cheat because he's actually a teacher that teaches it. I have somebody that does malware analysis, and you know what? I build my team around that. And I take all the easy flags, so they usually leave step 1 and 2 for me, and they jump in 3. But what I do for the team is I document. And we write up every single flag that we've captured, how we capture it, and the resources that we used. That way I contribute to the team, I contribute to the community, and I'm learning new things because I'm writing up what they did. Of course, I got to give a cloud guru a little bit of a plug here. We do have hands-on learning. My favorite right now, though, for those of you who I call neckbeards, and I do it lovingly, I promise, not so much, is Hack the Box. When you go to Hack the Box EU, you're going to get a page that's asking for your invitation. So when I got this, I called my friend. I'm like, hey, apparently I have to be invited to do this. You know, can you invite me because I know you're on it? And he laughed and hung up the phone. And I'm like, what's going on? Like what? So I call him back, and he goes, L, what CTF are you trying to do? Hack the box. Do you have an invite? L, what CTF are you trying to do? Oh, hey, I have to hack the box to get in. Just a warning there. All right, so for all of you who are listening, I know some people are on the phones, like everybody put your phone down, listen. I know that people have jobs to do, but I have one final lesson for you. And if you get absolutely nothing else out of the talk, listen to this lesson. And that's, it's okay to be new. With that being said, I'm happy to answer any questions you guys may have. Oh, wait, I also get to bribe you guys. If you want to come up, I have Choose Linux stickers, I have It's Okay to Be New stickers, and my favorite, because we all do it, is I have User Error stickers. All right, but seriously, any questions? Yes?
How does Untitled comment know
would absolutely love that. Also about the tool set, yeah, I've done that for about 20 years, now you can actually write my tools.
Amen. So lesson learned from him, document. Anybody else? All right, thank you very much for your time, guys.
1, 2, 3. Okay. Like this. 1, 2, 3. 1, 2, 3. Okay, let's see if this works. Yes, it does. Okay, so do we get network? Oh, your colleague beat you to it. Let's see if this works. Now if you'll hear me screaming. No. It does look right. Let's see. I'm sorry? Those are everybody. Thank you. Okay, we're good. Can you hear me? Sounds like it. Okay.
All right, good evening, everyone. Today, our speaker's name is Federico Lucifredi. He is a project management director at Red Hat, and he's going to be presenting Raspberry Pi and how you can turn it into a supercomputer. So please, let's put our hands together for Federico.
Thank you. So, usually I talk about computer security, and we go down the far end of the rabbit hole, so to speak. This time, it's more of an intro talk on how to build a supercomputer-like facility using very cheap hardware. And the idea is that we want to go on every single detail and make it very easy to do this, and to do this relatively quickly. So let's get going. So my former head of product marketing had always this rule that you had to introduce yourself, and so here's me. Like they were saying, I'm a product management director at Red Hat. If you go back, the decade, I've worked on pretty much every Linux distribution you can think of. A few systems management products associated with that. SUSE Studio for those who remember it, Landscape for those who use Ubuntu. Ximian Red Carpet if you go back 15 years. And for about 10 years, I was the maintainer of the Man Pager. And the reason for the funny picture from my publicist is that I wrote a book about Amazon AWS systems management. So that's enough about me. The usual obligatory disclaimer about hardware is that we'll break some, and it will be out of your pocket. So there are no warranties if you bring out the end of the world or stub your toe doing any of the following. I think it's not very likely in this talk, frankly, but there is always some smart aleck that manages to destroy some hardware, myself included. So it's just so. Let's look at how this came to be. So if you look at the table, there are two Pi clusters here. One is a Pi 3 cluster, and the other one is a Pi 4 cluster. screen to do this. And I'm going to use pictures because your eyes may be better than mine, but they are not good enough to see these. So this is a Pi 4 cluster. This is the Pi 3 cluster. You can kind of see that the Pi 4, because of USB-C and not much else, is twice as big. Obviously, it's more powerful, but not because of what you would expect. Really, what we want out of the Pi 4 is the switch, as it will be obvious towards the end of the talk. Pi 4s have actual gigabit Ethernet as opposed to the 4 gigabit Ethernet of the older Raspberry Pi. So this is pretty much a combination of existing hardware and self-built. This is the part that's self-built. Cases from Monoprice fit very well to carry this around, and both clusters made it across the US without breaking, so that works. The Pi stack pretty much looks the same for both clusters. It's a stack of boards held together by standard brass or, in this case, nickel standoffs. Nothing too strange. The kit with the pre-cut plexiglass was made by a company called Pico Cluster out of Utah. I think they are in Orem, but they're somewhere in Utah. These kits come with power distribution units that are already pre-built, so I didn't need to design any of this. The one for the Pi 3 is simpler. It's a simple USB, standard USB switch, and it can also carry data. The other one is a more complicated custom board to distribute USB-C power. And since there are higher voltages there, you can actually get blue smoke out of the big cluster if you don't pay attention. Here you can see pretty much how the build progresses. This is the complete stack for the Pi 3 cluster. And then you have the wiring, which in this case is pretty simple. It's all USB and an extension to bring out the HDMI. I think what's most likable about the Pi 3 cluster is how compact it is. And now it's also even cheaper, which helps. But the compactness is the nicest part. You can see there on the left the single power entry point and the HDMI for node 0. Only the head node has video access. This is the standard way the cluster is built. Those of you that can see this far will see that my version is slightly different. I found a switch that fits on the side and incorporated that. And I had to do a few things to make that work. Software checkout, we'll go into it in a second. So that's what I was just describing. So we have a 5-port switch, and we just bring out the physical Ethernet. Nothing too strange here. We extended the cluster a little bit with Pi Moroni blinked LED arrays. So obviously, it's a supercomputer. It has to have blink and light, and it does. And we'll get to that in a second. I don't have a picture of it, but the only problem that's left in this design is that there is no clearance for the power supply of the switch. So I had to go on eBay and find an elbow connector to turn the power 90 degrees so that it wouldn't hit the table. The rest is all pretty straightforward. The Netgear switch fits the size of this perfectly. So that's about the assembly and the hardware. We're not going to discuss what's in a Raspberry Pi 3 and a Raspberry Pi 4. We have better things to do. You already know all of that. Let's look at the software. This is the part that's interesting. So how do you make a bunch of different computers into a cluster? So first of all, this is a simpler kind of cluster. It's a numerical computing cluster. So we're not building a cloud, and that makes things a little bit easier. We just need to have users to distribute the workload across the nodes. We simply set up root, just because it has no password by default. Using the Pico cluster stock images, they come with a user called Pico cluster. You want to rename it to yourself or whatever you want it's called, because once you start, it gets very hard to do. You want to do this right at the beginning, and you want to nuke the xauthority file so that it doesn't block you because it's locked to the old user. So that's how you rename the user to whatever you want. And we're not going to see that live because it's not worth our time. But in the end, we have a cluster with your personal user and root, just in case you need a second user to be able to do operations. Maybe you lock yourself out of your account, or who knows what else happens. Root does not have SSH access, so if you're going to really lock yourself out, you maybe want a third account. Because of this flat structure where all users are the same in name, in UID, even in password, but we're not relying on that, across all nodes, this is relatively simple in terms of NFS. There is no NIS, there is no authentication. This is probably the only case where NFS is actually easy. And right, you could have a second unprivileged user Pi just in case. In this, I guess I got comfortable enough that I don't have that. Pi or ops are the usual choices. Let me see. If everything is working correctly, now we are connected to node 0. And we can see that I was logging in earlier today, trying to make sure that everything worked. No surprises there. So let's get to something slightly more meaty. What is the network laid out like? So we have two networks because we're using Raspberry Pis 3s and 4s, and this is actually pretty cool. We could do it with one network, but it would be slightly more complicated. Because we have two networks, we use the wired network for the compute purpose. So we hard code IP addresses to each board. They are fixed. It's always 10, 1, 10, 240 for the head node, and on from there. In this case, I have 3 nodes. You could have 10 or 20, it doesn't matter. These are always at this IP address, which makes coding your computing application, your numerical application, very easy. You can rely on the board name. You can rely on the IP address. Doesn't matter what happens. These are going to be fixed, which is typically not the case when you move a cluster. So usually clusters are unmovable because if your application is in any way depending on what you have in terms of IP addresses, it's going to have to be rebuilt. You could use DNS, but most of the time there is something getting stuck somewhere, even in enterprise class products. I know firsthand. But certainly in scientific code, where everybody gets pretty sloppy pretty quickly, you will never be able to move the hardware unless you do this kind of thing. So separating the network works really nicely. I have the physical network dedicated to the application. The cluster can be taken around to conferences, and it will just continue to work. The part that gets adjusted is the Wi-Fi network. The Pico cluster, by default, turns off the HCP so that it doesn't interfere and it doesn't change any IP addresses anywhere. So they ship with Wi-Fi off. We did one better, and we turned Wi-Fi back on, and we set it up correctly so that it is secondary to the physical network. So if you have Wi-Fi, it is primary for world routing. So if you try to install a package or update a package, it will go out through the Wi-Fi. But if the Wi-Fi is not connected or doesn't exist, it doesn't affect the operation of the wired network. So how did we do this? We did two things. One is we introduced the WLAN configuration of the interface in ETC network interfaces. And the thing here that is worth calling out is that we set up WLAN 0 before we set up ETH 0 on each node. And by doing this, if WLAN 0 gets configured and gets connected to a Wi-Fi access point, then the default route will go through there. So we don't need to muck with the routing. The default routing goes automatically in the right place. If WLAN 0 does not connect, then the default routing goes to ETH0, and there is no interference with your code. And the way this plays out in practice is, well, we'll see if it plays out correctly. Yeah, it looks like it did. It's default routing to the SCaLE network, and it has a local route just for our compute nodes. And we have WLAN configured and ETH0 configured. Now, this, if you're a virtuoso of Linux network configuration, you can do this just with one network. But it's not this simple. And since this is either something that you could use like I do to define processes and how you manage clusters, and just having a small cluster is good enough for me. Or the other application that you can have is teaching. The fact that this is way simpler than advanced Linux network configuration makes it ideal. So the other side of the configuration is that you have to configure the WPA supplicant to get you on the Wi-Fi network. And once you've done this, now you can install new software as needed through apt, usual thing, and you are even ready to visit Red Hat because you have our guest network password right there. Actually, that's our old Wi-Fi password, so the security guys won't complain. Don't get any ideas. So, if everything is working correctly, yeah, we have a working connection. Excellent. So, simple enough. Once you know where the steps are, it's kind of like Columbus's egg. Otherwise, you can fumble in the darkness trying to find these steps. Next thing, you don't want to be typing passwords all the time. So you put in access keys so that your user can talk to any other node without any authentication as long as it's over SSH. So usual steps, you generate SSH keys, you put them in the appropriate locations, and you set the right permissions for the right files, and then it all works. This is, we set the passwords previously, so if the keys don't work, or if you forget to put the key in place, there will be fallback to password. You don't get locked out. And in fact, usually the way I set it up is that I have keys from node 0, from the head node to the rest of the cluster. I don't have keys end to end. If node 2 wants to connect to the master or to the primary, whatever you want to call it, then you have to type the password because it's an unusual connection direction. But for primary to secondaries, it's all covered by keys. Now, one thing that the Pico cluster kit does very well is that it includes some scripts to do these things. genkeys.sh pretty much automates this process. And so you'll type in the passwords, and it will put everything in place. And once you get the presentation, there are links to the scripts from the Pico cluster crew. In this case, it's pretty much straight up this. Another thing that's worth mentioning is Dustin Kirkland's SSH Import ID, which is a tool that is downstream on Ubuntu. I think it should be upstream in Debian at this point, so it should be available for Raspbian. Use this to import the keys of a user just by saying, import the key of this user from Launchpad, import the keys of this user from GitHub. So it's a good way to give people access even when you don't know them yet, or you don't want to exchange 3 emails asking them for their public key. It just pulls them from their GitHub or Launchpad profile. Very convenient. So the other things that are already included with the Pico cluster automation are these things. Resize RPi is basically extending the size of the cards so that the images for the operating system covers the full size of the SD cards. And then you have a test facility, which works like so. so. And pings the 3 nodes and for all the nodes that you have, and gets back, in this case, df-h. The other 2 commands are to reboot the entire cluster or critically to stop all the nodes. Since these are SD cards, it's not that hard to corrupt an SD card file system by just pulling the power. So stopping the nodes and having a clean shutdown is critical. While I was preparing the talk yesterday, I actually corrupted one of the cards just by tripping the power supply. I didn't forget to turn off the board. I just didn't have the option. I just tripped the wrong cable. So these scripts make it a lot easier to maintain proper hygiene. One more thing that I would do is that I prefer to have these things in a proper place, which is the bin directory of the user. And because Raspbian is a Debian derivative, you can just create the bin directory, and then at boot, Debian checks if the user has a bin directory and adds it to the path. So you don't need to add it yourself. It's self-adding. You can just move things in there once you have them squared away the way you like them. Also, I hate the .sh extensions for shell scripts, so I yanked those. But other than that, those scripts are pretty much good to go as they are. Maybe you need to change some usernames if you rename the usernames like I do. So that gives you cluster automation basics for things that you're going to do all the time, like stopping nodes or restarting nodes. But what about things that you're going to do only once in a while, and that you need to do from all nodes? For that, there is parallel SSH. So in the example here, we're going to all servers specified in the nodes file and reading what's in the hosts. Basically checking that the static network configuration is done correctly. If you look at the second example, that is how you look for a problem. Or let me just show you. So, oops, I copied one character more than I meant. Oh, I didn't mention this, but for an intro level audience, it would be worth mentioning that in the slides, what I preface with the $sign means unprivileged user. What I preface with the £sign means root user. It's a shorthand to avoid writing do this as root all the time. I should have just typed instead of trying cut and paste. What? Oh, and there is even some Unicode thrown in. Do you see the quotes there? So I guess we will just type. So this is the way parallel SSH usually works. It just tells you, I got a good exit code. Isn't life grand? But it doesn't show you what actually happened. And this is the second example. If you go and say inline, you will actually get the output. So you can check what's happening on each node. And you will see, well, there is a Raspberry Pi, localhost alias, I'm not sure why. And maybe you want to get rid of that. There is also a PC4. Well, this cluster really has only nodes PC0 to PC2. We could drop those. In any case, that's the core of parallel SSH. You could similarly check connectivity. Let me see. Where is my cursor? So what is H nodes? H is a way you specify where you want to go, H file. So the nodes file is just one host name per line. The other way you can specify this is that you can have capital H, and you can list the hosts individually. -C1 -W5. Yeah, let's say 5. Okay, this one, again, I didn't use the inline, so I just get that everything succeeded blindly. The reason why I timed out the ping with ping only once with C and stop after 5 seconds is that if this failed, it will most certainly fail in honor of our keynote speaker this morning, and it would be a DNS resolution failure. So if you don't time bound it, it will try for 3 minutes, and you'll be waiting. On success, obviously, it returns immediately. There is one more thing that is an obvious example here. One thing that you'll be doing all the time is updating the nodes. So you can dispatch a sudo update to all nodes this way, and then you can actually upgrade all the nodes if you're that trusting. Time. Time is relatively simple. You just go to systemd, time date control, get the current status. You can get the results out of the other location, and you can get the actual definition of where the time server is in the systemd file. Now, to be able to do something useful with the cluster, you have to have a place where the files are. So just like we don't want to be changing permissions all the time, so we create one user across the entire cluster, we make authentication safe but transparent, and we give everybody the same user ID in case that ever matters. The other thing is that when you're writing code, you don't want to be copying new versions of the files around all the time. So you set up an FS. In this case, because of how flat the hierarchy of users is, it's really trivial. It's 3 lines to set up the NFS server and 2 lines to consume it. The only pitfall here is that the mount is coming from FS tab in the client. You're going to be editing etc FS tab, and if you get that wrong, the boot sequence of that node will fail. So do not fat finger edits to FS tab. But other than that, this is pretty much all that you need to do, and it looks like this. So on node 0, we pretty much added this one line saying everybody that's on the subnet that these nodes have the private physical network on can access without password. Since that network is physically separate, why not? And SSH, let's try another node. And this line here is basically mounting the share on the first secondary node. Okay. Besides the FS tab corruption, this is really the simplest NFS setup that I've ever done. So no complaints whatsoever. Now, what else? Last bit of configuration for the cluster is how do we use the lights that I was talking about. So we have arrays of LED lights on each board that can be used to relay status. There are 8 lights and they are RGB, so you could decide that each light has an independent meaning based on color. You can do something pretty obvious, I guess, like this. So let's start using our export, our shared directory that everybody has access to. So we have just one copy of the script for everything in the cluster. And basically, this is just scanning the LED. It's on the side of the box, so we'll turn it. And we can do pretty much the same thing. But I'm going to be lazy and not type it. And we can pretty much dispatch the same command to all boards. Now, this is funny, and it invites whatever silent jokes you want to put in here. But it's much more relevant to show some actual useful data. So let's try to do that, shall we? So first of all, let's clear those signs, and then let's try to, well, let's just do the top one instead of blinding everybody with too many LEDs. So this should be running only on the top one, and this is pretty much showing the load average of that node. So if I go over here and I need a second terminal. Where I put my second terminal? Here. PC 0. $240. I'm just logging in a second time. So there is a command called stress that is used to put load on a system, and I'm going to launch two CPU stressors on this. On this node. And now you see that it's higher. And as soon as I kill stress, it goes back lower. So you have a little bit of visualization of what is going on in terms of the CPU load. You can write, these are pretty simple Python scripts. So you could write whatever Python visualization you want about the state of the individual nodes of the cluster. And that is one more thing. Let me see. What do I have here? Okay, clear? Good. These arrays can be programmed in Python 3, in Python 4. They're pretty easy to use, so not much surprise there. The only caveat is that you need to have a little bit of pause between the updates, otherwise you see as much flashing as you have seen right now. Maybe the speed of update is not as prized as not giving people seizures with too many flashes. So maybe slowing it down a bit would be a good idea. But that's entirely within your control because these are 20, 30-line Python scripts at best. Most of the work is just getting the data into a form where you can get to show it. So here. Let's see. So why is this supercomputer? It is a supercomputer if we start using the message passing interface. So most parallelism in the supercomputing sense is done by passing different data to the same compute code. So multiple data, single code is basically the prevalent model. And that's what MPI does. You write a segment of code that's meant to process one problem, and then the data region is being fragmented based on however many cores or however many CPUs on however many systems you have. From the point of view of MPI, it doesn't really matter if these cores are all in the same processor, or if they are on different processors, or they are on different systems. Obviously, the farther apart they are, the slowest the communication will be and the higher the overhead. But from the point of view of the code, it's exactly the same thing. Now, I documented what you need to install to make this work, but we're obviously not going to do that. The MPI compiler is MPI-CC. It is pretty well-established technology. You can find it on any Linux distribution you want to think of. And we have a couple of examples. So let's try this call prox example first. So this one doesn't do any computation. It just tries to split a workload into multiple chunks. And I think I'm sorry? Oh, sure. So we're going to go. This is one example. It's a very simple bit of code. This comes from a book by a NASA scientist called Carlos Morrison that was writing books about Raspberry Pi-based supercomputing already, I think in 2016 was the first time I saw something. This is his simplest example, and all that it's doing is splitting the problem into a sufficient number of data segments for the number of resources you asked for. So MPI exec is how you launch a C program compiled to the MPI interface. -N8 means that I want it split in eight ways for data, and then that the executable is called callprox, which is the code that I built using the example in the slides. The code itself is not doing anything. It's just allocating the different threads and then joining the results at the end. And so we can do this with 8. We can do it with pretty much any number that we please. It's just going to change the split of the data. Nothing too surprising there. The other part, the other example that we had here on the slides is this. At the bottom of the slide, you see that -H, where instead of saying, give me 8, I'm saying, I'm giving you these cores. Now, the way you address cores in the syntax is that you basically give host names. And in this case, I'm giving the host name of secondary node 2 and secondary node 1 4 times, because I know that these machines have 4 cores. So if I do things this way, what I'm going to get is, let's see, 607. Oh, where is my cursor gone? Here. Yeah. Same result, but if you compare to the previous one, previously all the 8 threads were on node 0. Now they're running on 2 different nodes. We're actually sending the data across the cluster itself. And we have 12 cores in the cluster, so we could go all the way to 12. We just haven't because it takes a lot of space on the screen, but we can do that. Here is a different example. We're running here this code that's called MPI08B. This is another code from Mr. Morrison's book. And all that it does is it integrates very slowly. It integrates the first, I can't remember how many digits of pi, I think 48 digits. There is a very long tradition and a very large number of codes to try to calculate pi faster and faster, and Morrison's book has at least 3 or 4 different codes to do this. This one is an interesting example because it allows us to do this in about a minute a run, so that you can actually see it. So I'm going to chunk this up in 100,000 integration segments. This is numerically approximating integral, and it's going to do it with 100,000 slices. With 12 cores, as I've given it right now, it should take about 25 seconds or thereabouts. While it's running, let me mention one more thing in the slides here. So the easy way to measure execution time is just to say time before the command itself, and that will run the bash built-in time, which most people should be already familiar with, but this is an intro-level session after all, and it will just tell you how long in wall clock time it took to run that command, and how much kernel time and user space time was consumed. Now, I want to run, I went and run those 2 examples earlier. The one with 8 cores took 26 seconds. The one with, actually no, the one with 4 cores took more than a minute and a few seconds. I can't remember if, yeah, the one with 8 cores, I don't remember how long it ran, but the one with 12, which we're running here, should have taken, this one didn't work. Oh, I know why. Yeah, it's my fault, as usual. We were idling in the time variable because I didn't give it the 100,000 input while I was talking. When it is not holding there waiting, it takes 25, 26 seconds. This is using 12 cores. And I was telling you before, when you are using only 4 cores, it takes about a minute. So we are making it 50%, we're making it twice as fast. We're making it so that it takes 50% of the time, but we're using 3 times the resources. So that's why there is that humorous quote there from modified version of Blade Runner, because there is overhead to parallelism, obviously. You are wasting a lot of resources. This is codified in a number of formal laws, like Heimdall's law and so on. But effectively, you are not going to get linear speed up. You're losing some performance. So if it took you X with 1 resource, when you go to 2 resources, you're not going to get 2X. You're going to get less than that. Now, if you could get linear speed up, it would be awesome, but you can't. It declines and declines, and it approximates a number that I'm not going to go into. But the important bit here is that you can throw resources at the problem, but only so far. And obviously, it's going to cost in time and in CPU. For many cases, it's a fine trade-off. It doesn't go indefinitely, however, which is why usually when people are reading stuff and you say, I'm going to make it twice as fast, they raise an eyebrow. When you say, I'm going to make it 10 times as fast, they go to Heimdall's law and various collated things, and they just go, that's impossible. You have to prove it to me that you can do it 10 times as fast, because up front they know how difficult it is. But 2x, despite the fact that marketing almost always lies, and it's not true that things are twice as fast, 2x is possible, and sometimes it's true. And certainly, in terms of parallel computing, it is possible to get 2, 3x reasonably easy. It's beyond that point that you really need to get to the details to see if you're getting a real fair comparison or if people are changing the terms to show you good numbers. In terms of the hardware that we're looking at specifically, the biggest change going between the Pi 3 cluster and the Pi 4 cluster is not the fact that the Pi 4 cluster has twice as fast CPUs and that those are Pi 4s with 4 gigabytes of RAM, so we have a lot more RAM. That doesn't matter. What matters is that the Pi 3 has the fake gigabit Ethernet, and the Pi 4 has real gigabit Ethernet. So the performance improvement from Pi 4 is coming from the fact that you have real switching there. The overhead of distributed computing is almost always coming from the network. So first you have the problem of how many ways you're going to split the problem, and can you split it in a sufficient number of small pieces without getting buried in overheads. Then the second bit is going to be, is the network fast enough? Because the network is way, way, way slower than the CPU. And there are many humorous visualizations of that, basically saying something like, well, one thing is going over there, grabbing a sandwich and having lunch. Another one is driving to the farm, collecting the lettuce, killing the pig, making a prosciutto, and 3 months later coming back here and having a sandwich. That is the comparison in speed between what's going on in the network and what's going on inside the CPU. And that is not a joke. Those are the same orders of magnitude, 3 months versus 60 seconds. That is why the switch is so critical in this case. Of course, you can only go so far with Raspberry Pis, but you can build this, the most expensive thing that's on the table, you can build for $400. So this is a reasonable setup to train a student in terms of how to do MPI programs. It's a reasonable way to develop protocols for how are you going to manage upgrades and distribution of keys or the stuff that I was describing at the beginning. Obviously, it's not the real environment to do your supercomputing. But you can write the program here, and once you have the program working, you carry it over to the expensive hardware. It should be compiled just fine, and it should just run just fine. So it's a convenient, cheap tabletop supercomputer in a sense. And obviously, when you have a real supercomputer, you have real switching. You can get 30 gigabit, 100 gigabit, whatever it is that the amount of budget allowed you to get. So I hope that I've given you at least one or two useful thoughts. It took some time to build out. This is kind of the first revision of this. I'd like to add a few more numerical codes and a few more examples going into detail. If there are ideas, I would be interested in hearing them. If there are questions, I would also be interested in hearing them. Remember that speakers are Pavlovian devices, so we need feedback to know which way to go. There is also going to be, at least I plan to have an article on this on opensource.com, so at some point you have all the notes properly written instead of shared as a bunch of slides, which are not exactly a good tutorial for documentation purposes. And that's what I have. Questions? Yes? Not really with the Pi, because the problem of the Pi is that everything is going through the USB controller. And so even Ethernet is going through USB. So it is rated at 1 gigabit. The interface, the SPI that's putting out is 1 gigabit, but the performance is not. There are probably other boards that are a little bit more performant than that, but as I said, the Pi 4 has real gigabit Ethernet, but it's 1 gigabit. I'm not sure if there is an SBC that's able to provide you 10 gigabit. I haven't seen one. So at that point, you have to move into the real hardware kind of game. Yes? Can you run a multi-node database on the Raspberry Pi? Like MySQL? Yeah, you definitely should be able to do it. I think that the binding limit there is memory. The Pi 4s with 4 gigabytes seem like a reasonable choice for that. Yes. Yes. SD cards. Yeah, I think it's a SPDX, but it's 32 gigabyte. I think the limit is the same. Yes. Yes. A mini cube? Oh, hosted here. Yes, actually, while I was musing about breaking one of the nodes yesterday, Rob Hirschfeld, who's one of the former board members of OpenStack, and he has his own company doing bare metal provisioning. They changed names. I think it's Digital Rebar is the current name. If you send me an email, I'll give you the links. But basically, he sent me a note saying that he had made automation so that you could go from bare metal to Kubernetes in a 3 or 4 node Pi cluster using his system. So that seemed like an interesting demo. I haven't tried it, but Rob usually does excellent work. Yes? Yes, but because the network performance is the bottleneck, caveat emptor. But it will work. It will work. It's just a question of how far you can push it, right? Yeah, you're not going to establish any speed record, but if you look at it, I have clusters in my office where I build these clusters that I like to call the slowest clusters for X. And basically all that they can do is running X. You can never put any load on them, but you can actually see this code in operation, which is what I'm interested in. And so if I can do that with less than $10,000, for me is a win, because it would be the cost of one machine. Obviously, none of my clients would do that in production because they would laugh. It's like, how many transactions can you serve out of this? I don't want to serve any transactions. I just want to see the code running. There was somebody else, but I lost track of the hands. Yes. General parallel computing textbook recommendations. It's always been an area where there's been not much that's been good. And that's going back 30 years. For MPI, the best stuff is coming out of the MIT press. I think that they updated, at some point in this decade, there was an updated version of the MPI book out of the MIT press. That was the most recent version. There is a lot of excellent material for parallel computing done in GPUs. So NVIDIA and that kind of acceleration. Or even Intel, what is it called? Knight's Corner and those type of accelerators, which actually resemble clusters more than the NVIDIA environment does. For those, you can find reasonable documentation. But for supercomputers proper, it's really hard. Actually, we have the publisher of No Starch Press at the conference, Bill Pollack. You should pitch him a book on that. All right. Thank you.
Hello. Um, 1, 2, 3. Testing. Is this too loud? Is it good? Good.
Are you there?
On the contrary, think it's a little too loud, but all right. Like this? Okay. Cool.
Un minuto. Shall we start? Is it too loud? So a little feedback, right?
Oh, wait, actually, one more minute.
We have 1 minute. We're gonna just stare at each other for 1 minute, and then we are going to start. Well, before we start, I don't like being in that thing. I want to ask you, who uses Fedora? Raise your hand. Red Hat? CentOS? So we are all like RPM family, right? So we can assume that we already started. Oh, there's oh, hi. We met them at the hamburger place. Very good hamburgers here in Pasadena, and beer. Well, I am Ivan Chavero. I work at Red Hat. On the GLS part, I write the books you use when you want to get certified. Here's my friend Alejandro Acosta. And here's my friend Perry Rivera. They are very good at computers, and you can show your powers on the slides. And we're gonna talk about Fedora. How do you pronounce Fedora? I say Fedora, but it's Fedora 31. And we're going to talk about Fedora 31, and we're going to show you some of the cool stuff we have found and we like to use, mostly desktop. But if you have any question about server stuff, we are happy to answer. And I give the microphone to Perry. He's going to start the talk.
All right, hello everyone, and thank you so much for coming today. Before we continue, here's a QR code for the slides. Feel free to grab a picture of that. There's also a hyperlink underneath that'll allow you to browse a PDF of the slides that we're about to take a look at. All right? So the agenda for today is we're going to be discussing Fedora 31 highlights, what's new with Fedora, and a brief history of Fedora, and then how to get started with it if you haven't used it before, and how to ask for help. So about the speakers, I work out at a medical company over in West Hills, providing troubleshooting and technical support, as well as for various clients throughout the San Fernando Valley. And then I'll hand the mic over to Alejandro Acosta.
Thank you. Well, as they mentioned, first of all, thank you for being here. I'm Alejandro, I'm Alex. I have been a contributor in Fedora for more than 12 years. I started in 2008. My day job is a DevOps engineer at Softec. It's LATAM's biggest IT company. Most of our clients are here, located in the States, so it's like 90-something% of them. Also, I am a founding professor at the University of Chihuahua in the Free Software Master Degree. I like to speak, contribute. I free software enthusiast. I like to participate in communities. I am old enough to call myself old schooler, and recently I have earned my Kubernetes administrator certification, as well as chef developer. And that's me, and again, thank you for coming to the talk. Ivan.
I am Ivan, and I like beer, and let's keep talking about Fedora.
All right, so what is Fedora and what's new in Fedora? It's a GNU Linux distribution. It's 100% free and open, innovative, stable, and secure. And our mission is to lead the advancement of free and open source software and content as a collaborative community. The 4 foundations of Fedora include freedom, friends, features, and first. Freedom is 100% free, legal, and redistributable. Software, artwork, project code, and everything. And we're never cutting any corners. Second is friends. So as you can see from visiting our booth throughout the week, we try to bring our community together. So that we like to talk with people, find out how people are using Fedora. So if you have any questions, concerns, complaints, things like that, we'd all love to hear it. So feel free to stop by our booth, booth 512. Also, in terms of features, we tend to bring in a lot of the newer features. We're the upstream section and so all of the features come in through us first. And so our features then become part of other distributions as well. And then innovation. So we don't wait for others to do the heavy lifting. There's a rapid release cycle every 6 months, and the community R&D lab. All right, so in terms of a quick history, so back in 1969, Ken Thompson and Dennis Ritchie implement Unix. And then 1983, Richard Stallman starts the GNU project. 1991, the Finnish student Linus Torvalds creates a new free operating system that later becomes the Linux kernel. And then 1994, Red Hat Incorporated creates Red Hat Software Linux Preview, beta. And then 1995, Red Hat Incorporated releases Red Hat Commercial Linux RHL 1.0. In terms of a little further later, there are some additional RHL releases. And then 2003, Red Hat Incorporated releases the second beta of Fedora Core FC 0.94. And then from 2003 to 2006, Red Hat Incorporated releases FC1 through FC6. And then 2007 down to 2020, there's Fedora 7 through 31, and then code names are dropped beginning 2013. So to get Fedora, it's pretty easy. You just go to this website, getfedora.org, and there are different categories. You want to discuss them? Or okay. So the different categories are workstation, server, cloud. Server is for specialized servers. Workstations are for general use. So if you want to download something for home use, that's probably a good one to start with. And then there's cloud for cloud computing, and it facilitates container storage, container usage, excuse me. So in terms of the different flavors of Fedora, we have spins. So not very many people know about this, but we wanted to let you know. So just go to spins.fedora.fedoraproject.org, and there are various flavors of it. So KDE Plasma, XFCE, LXQT, if you like some lighter weight distributions, Mate Compiz, Cinnamon, LXDE, and SOAS. We also have various labs available for specific uses. We have an astronomy lab, a design suite lab if you like working with photography, creative types of ventures, a Python classroom, a security lab, and finally the robotics suite. Also, if you happen to work with ARM, we do have arm.fedoraproject.org for providing functionality for ARM servers. We have the full image weighing in at 507 meg, or if you want a minimal that you can build up from 362 meg. Desktop computing, we have KDE, XFCE, similar situation, and then also the ARM labs of Python Classroom. Okay. So to get Fedora on your system, basically there's a tool called Fedora Media Writer, which runs on both Fedora operating systems as well as Windows operating systems. You download this app, and it allows you to burn an ISO directly to a USB thumb drive, and then you can boot off of that to get the ball rolling. So how to ask for help? You can talk with us over at the Fedora booth, booth 512. We'll be happy to assist you. If we don't know the answer, we'll try to connect you with people who can assist. We also have ask.fedoraproject.org. There's various forums, fedoraforum.org, where you can post questions. There's an IRC channel, #Fedora. You can use apps like Riot, for example, to post on there, and then a few hours later you may get a response or an immediate response, depending on if someone happens to be there who can answer immediately. There's also a mailing list. Feel free to add on to that if you'd like to post your questions directly that way. Documentation is at that link over here, and then the wiki is there, and then the Reddit is there, if you haven't already discovered that. Okay? Then for Fedora 31 Workstation, here's a link to the entire documentation for that distribution. So feel free to check that out. And also the announcement for Fedora 31. Very helpful. Please check these out. Some of the new things in Fedora 31 Workstation include GNOME 3.34, which we'll be discussing a few slides from now. And then beginning removals of the Python 2 package. So around December, upstream support scheduled end for Python 2. And then there are also a few Wayland improvements and continuing work on X-Wayland, as well as kernel 5.5. And then also for Fedora Toolbox, which Ivan will be discussing in a few moments, Silverblue, CoreOS, and IoT topics. So GNOME 3.34, codenamed Thessaloniki, is a nod to the annual conference held in Greece. There's support for GNOME games, so if you happen to play and use snapshots, you can now snapshot your progress and move to other devices and continue from there. That capability wasn't there for previous distributions. There's also a background chooser that seems kind of simplistic, but the thing is, this has been sorely needed, especially in GNOME. So that's kind of handy to have, and so we wanted to describe that. Also, there's a custom application folder. If we have some time, we'll try to demo that. It seems a little quirky and a little challenging to use, and we referred that quirkiness to the GNOME team, but time permitting, we'll show you why. Okay? And then there's also boxes. So if you use the boxes tool, it's a feature that allows you to run VMs within your environment. And the new Box Assistant workflow is a lot more intuitive, and existing VMs now explicitly can be booted from an attached CD or DVD image, enabling you to rescue broken systems or simulate dual booting environments. So, and if applicable, and the 3D acceleration is supported, it's now an optional setting that enables you to opt out of 3D. In terms of accessibility, which is useful to a lot of our developers and users, their mouse accessibility on both X11 and Wayland sessions is now present, as well as hovering the mouse for hover click. All right. And then I'll hand you over to Alex for Podman.
All right, thank you. It's just a couple of slides, and maybe if you help me with that, it'll be easier. But okay, Podman. Podman, it is a container engine that allows us to develop, manage, and running OCI containers. OCI stands for Open Container Initiative. So that allows or ensures that the containers are not attached or vendor specific or technology specific. We all familiar with Docker? Yeah. We at least have heard what Docker is, right? So if we already have Docker, why we need Podman? Well, Docker provided friendly way to manage a technology that has been used for some years now, which are containers. So Docker came and made a set of commands and technologies that allowed the massification and the spread of containers technology. But using Podman provides us with a couple of advantages. I mean, we were supposed to have a little demo. We're not going to do it because we have to switch laptops and all that stuff, and we don't want that to fail. But if you have a session, well, let's get crazy and try it. I'm in a SSS session somewhere in Ivan's infrastructure, but
My laptop over there.
all right. If I try to run any container from the internet, the first problem that I'll face is that I don't have I cannot connect to the Docker daemon. When I use Docker, I have to use a process that is running in the background, a daemon, that it is needed for running Docker containers. So with Podman, it is daemonless. You don't have that daemon running in the background. Actually, I can run exactly the same instruction, but instead of Docker, use Podman. Dash TI? TI, right. Unknown flag. Come on, Ivan. So the thing is that there are two advantages. You don't have to use a daemon, and you can run your containers either as root or in a rootless fashion. Sometimes running your containers in production using the root represents some security challenges that you might want to be aware of that. And one way to avoid them or to run containers in a more secure fashion is precisely by using Podman as a regular user and avoid intrusion to your infrastructure to other levels that your container have access to. Ivan is running a new image based on Alpine, and as you can see, it's exactly the same command that you would use in Docker, just replacing Podman. So you don't have to learn a lot of new instructions if you're already familiar with Docker. I think we should leave it like this, not to get too technical. I just wanted to talk about those two features of Podman, daemonless and rootless. Rootless, as not being root. And in the slide, that is a way, and you can run all of the Podman commands. Also, if you don't have Docker installed, but you are familiar with Docker, you can use an alias and point Docker in Podman, and you can use all of your previous scripts with no more effort than that. Can I have the next? We saw an example using run hello, and yeah, that one. So there is no run. There is no need for any further explanation of this. But if you have any more questions on this, feel free to approach us, and we'll be happy to assist you. The next one is about Toolbox, and I will ask Ivan to.
Yeah, this Toolbox thing is part of Fedora Silverblue mostly, which is an immutable operating system. That means that you cannot modify the operating system unless a centralized server allows you. So there was a necessity to install and do stuff using the shell. But you can use this Toolbox in any Fedora version after, I think, 30. And it's pretty cool because instead of running podman, blah, 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 you just say, I want to run a Fedora 33. For example, you have been in the position of having to run some rawhide application in your Fedora stable, right? I think you have, no, you never? Really? I thought you were like cowboys trying to go into the unknown. So, well, I usually need, for example, when I'm trying to compile something for GNOME, I need the rawhide libraries which are not installed in the current Fedora because they're so new that, well, they are not there yet. Or your packaging, for example, you have to test your package in a rawhide environment, and instead of launching a virtual machine, you can just say, hey, Toolbox, give me a Fedora 33. For example, we are now on 32, is beta, and 33 is rawhide. So we need those libraries, we need to check a package, whatever, we can enter a container, but instead of saying podman ti blah, 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 we just say toolbox, enter this container and this version. So that's pretty cool for a developer. I think for a normal desktop user, for example, my girlfriend, she doesn't care. But from a developer standpoint, it's pretty cool. It's pretty important. I was going to do a little demo about it. I don't know if it's going to fail. I think. Shall we fail? You like to see blood. You like. We love error messages. I think I have a screen session with. No, I don't. Well, I'm gonna try it. What did I do? Toolbox list. Let me check if I have some environments already there. Shall we create one or just enter? Create one? Yeah. Let's fail. I don't remember the. It's too long. Okay, as you can see. Can you hold this?
I can hold.
This is the container name. No, please don't do that. I'm gonna feel like Madonna. I'm gonna start dancing. Yeah, I don't like those. What? We're missing the thing, the stand. And we can say which image. English keyboard. Org. And we want, I'm on Fedora 31. Which one we want? 30, 32, 33. 40. We can put 40 and it's going to fail. You guys want to see it fail? 33? Okay. Oh, it's elite. And then there's the internet connection is slow. So okay. Now it says this is nice because I didn't remember the proper command. So let's pray. Okay, while this is happening, imagine you're creating something like you want to test a RPM package for the next Fedora version. So it might fail because it doesn't have some libraries or some environment or pre-configuration. Oh, failed. Thank you. Let me. I already ran one, so let's check one out. Let's see if this one works. The one that says test always work. And there it is. It works. And even have history. So we can see we have a Fedora 33 in here. And it's like you have to test stuff, or, for example, you need to have some different environment from the one you have in your desktop machine, and you don't want to make modifications. For example, it has happened to me that I install some libraries and they conflict with I don't know, something of the graphics, or something gets overridden, or you want to test a different configuration of a mail system or whatever. You can use this stuff to do this task. I don't know if you guys have one question about this, or it's pretty straightforward. You want to talk about C groups?
So beginning in Fedora 31, C groups is set on by default. So if you've been using C groups V1, just keep that in mind. Fedora, we've decided it's time. So definitely there are features and fixes to things in C groups V1. Definitely take a look at this documentation here if that concerns you. Also, if you remember one thing from this talk, C is for version 1 only, and C run is for V2. Okay? And then also, if you need to upgrade firmware, there is this GNOME firmware tool from flathub.org. We've included the link for that, and check out that blog there. If that's been a point of contention where you had to update, okay? And kernel 5.5.
Yeah, this is weird because we used to have pair numbers in subversions of the kernel, and the current one it has 5.5. I don't know why, but it's interesting. I found it interesting to mention it. And one thing that I like is it has now Raspberry Pi 4 support. The last time I installed that in Raspberry Pi, I had to compile my own kernel from the Raspberry Pi GitHub repo. So having it now in Fedora is pretty convenient. There's also some export enhancements that allows you to use less fragmentation, less space for your file system. It has support to Thunderbolt 3. The lockdown feature that it's actually from kernel 5.4, but I wanted to mention it because it's pretty interesting. Mostly when you're talking about embedded systems, or if you have a big server farm or virtual machine clusters, this kernel lockdown feature is pretty good. It's basically taking out even root privileges from the super user if you desire to. So if the main administrator says this has kernel lockdown, the root user cannot modify kernel stuff. So that's pretty awesome, and has a lot of graphics drivers that I was going to put all the enhancements of the graphics drivers, but you just can look it up on the release notes of the kernel, or you can just install Fedora and enjoy that stuff.
Want to talk about it?
All right. Okay, give me the next one. Upgrading to Fedora 31, assuming that you already have Fedora installed in your system. There are actually two ways. One is using the graphical interface with GNOME. That is pretty straightforward. Or through the command line interface, we first have to install the DNF plugins for upgrading the system. Then in the third line, we download the packages for the release that we are interested in upgrade to, not from, but to. And after all of the packages have been downloaded, just issue the last command for in the next reboot, which will be invoked with the command. The packages will be installed. Even if this other way seems a little more harder, it's really pretty straightforward. And talking about my experience, it's painless. I mean, there aren't. I mean, we have passed those ages when we have problems upgrading. For the last 10 releases, it has been very straightforward and painless. I don't know if there's something else. Okay.
Just adding something, because when we explain this, the Gentoo guys always say, "Oh, you have to reboot, you suck, you're like Windows." But remember, a system upgrade is about libraries, and the C library, the kernel, and a lot of stuff that you really need to reboot in the end. So if you upgrade live all the libraries, suddenly Firefox loses its icons and nothing runs anymore. So this is a proper process to upgrade the system. Just to add that, because I know somebody is thinking that. I know someone over there.
Who, me? All right, so looking ahead, so on the radar is NF tables. It's a replacement for IP tables, IP6 tables, and family. So begin to take a look at this as, especially in terms of security coming down the pipe. We wanted to be sure you're aware of this coming up, okay? So if you have any questions, visit us again at booth 512 in the expo hall. My name is Perry, this is Alex, and this is Ivan. Additional thanks to Brian and Scott for, as well as Nemanja for the slide template. So if you have a survey, let us know how we're doing. If there's anything you wanted to see in this presentation, or if you liked it, please let us know. I'll leave that up for about a minute, and then I'll give you the code again for the slides that we just saw. Okay. All right. So, and so here's a code for the slides again. So if you missed that earlier. Okay. So are there any questions here before we break? Okay.
Sorry, we have been asked to use the mic for the recording. Okay, to repeat the question, how is RPM modularity working out in the cloud, and are there any tutorials for people who use RPM tooling internally?
So I personally myself don't work with modularity. However, I do have associates at our booth, Scott and Brian, who may work with modularity. So stop by our booth between now and tomorrow, tomorrow, and we'll be able to assist you with modularity questions. So, all right. Next question, Larry.
My question is about the Silverblue technology. Is Toolbox one of the tools that's available to Silverblue? And you mentioned something about, I don't know, it appears that what it does is allows you to run developer tools in a container, but you're able to run GNOME as well?
No. Well, the Toolbox is, the origin was for Silverblue originally, but it runs everywhere. The point is, since Silverblue is immutable, you cannot install RPMs or anything. You have to create a container for doing that kind of stuff. When I said GNOME stuff, I said like compiling stuff for GNOME, not running GNOME. But you can have like it's mostly thought of as a development environment or an alternative environment for the one you have on your machine.
Are you familiar with any problems with the latest kernel release 557?
Not really, but they must be a lot, I think. It's software. I'm not really familiar with all the problems. I'm familiar with that one particular problem. For this thing, use NVMe as a hard drive, and for some reason it doesn't work. So I have to use kernel 4.16. Please don't hack me. It's the only one that is currently working. But there are, as in all kernels, there's always some problems and a lot of 0 days that we don't know about.
One more question. What's the difference between a pod and a container?
Well, a container is like a chroot with steroids that uses C groups and namespaces for create isolation and resource limit. C groups are for resource limits, namespaces are for isolation. A pod is a set of containers. So it's like a container for containers. But I wouldn't know. I don't use that stuff. I don't really know the Docker environment. But yeah, you can think of it as a container of containers.
Any other questions? All right. So if you have any other additional questions for us, we will be at the Expo Hall again tomorrow. Feel free to stop by. We look forward to seeing you again soon. And thank you very much for using Fedora and for your interest. Good night. Okay.